Clearly, by the way. Wow. Clearly, I'm not ready. Like, yeah. So, for those of you who don't know, I didn't know this was going to happen. I had some housework that needed to be done. It's Jubilee weekend, so I'm actually doubly surprised. I got started about an hour later than expected, thus finished an hour later than expected, which has thrown my schedule for today off, clearly. My apologies about that. So, welcome in, anybody and everybody. So this is a bit different than my normal videos in the sense that I, up until a few weeks ago, wasn't really doing live streaming. Now we are twice a week on Fridays at 5, British Summer Time, and 12:30, allegedly, on Saturday when I don't have work being done at my place. And on Friday night, it's community night where I'm usually doing some prep work either for something I'm working on or something that's going into a tutorial, or sometimes a combination of both. So like 2 weeks ago, because we didn't have last week because I was very, very ill. But 2 weeks ago, I was working on a RTS bit of code that I was been commissioned to write. And it's actually that code that's serving as the basis being the keyword, for the new RTS Remaster series. And I say the basis because it's not replicated like the C++ code is, because it's a multiplayer game. It's not going to have the individual features. Hey Mohammed, how you doing, man? And welcome in. And on Saturdays, what we typically do here is I usually do some neural network coding. Got some bad news for people today. We're not doing that one, cause I have a bit of a surprise for you instead. And this video today, or this live stream today, should be called Game Engine and Game Engine, as a hint for what the surprise is. As usual, I will be doing the Game Engine series C# side of it, because I don't do much with C#, and what I have done with it hasn't been with the XML or XAML file. It hasn't been GUI stuff like that. I haven't been making my own GUIs. I've been doing things in Unity. Or, yeah, because I only use C# for Unity nowadays. So it is a learning experience for me as well in other ways, and I'm enjoying that. So we'll keep that up. But, as I said, we have a surprise. Now, before we get into that, as always, these live streams and the tutorial videos I produce are brought to you by Patreon sponsors, and you too can help this channel out. All you have to do is hit that like button if you haven't already. So, what's stopping you? And if you want to be here or know when the new tutorials come out, when the new live streams are happening, even though they're scheduled, except for me being late today, then, you know, make sure to hit the subscribe and notify icon. All right, with that said, let's get on into it. And hey, Sam, welcome in. And after I do the little intro, I'll ask you how you're doing, Sam. So I will see you all in just a moment. Hang on one second. Okay, the microphone was on this side too. Okay. Sorry, I had a moment where I was like, was the microphone not on the entire time? If it wasn't, yikes. OBS, you're starting to be a bit of a... So, Sam, how are you doing today? Welcome in. Happy Jubilee, Josh. What are you doing for it? And yes, I remembered who you were. Which is why, again, I'm surprised I was late, because, again, I had work on my house done, and it happened an hour late. Well, one, I'm surprised, one, that it's Saturday I'm having it. Two, it's Jubilee weekend, so I'm doubly surprised. For those of you who don't know already, despite my American accent, I live in sunny, never sees a drop of rain, England. I'm trying not to laugh at my own bad joke there. Hey, Kiwi, welcome in. So, again, today we're not going to be doing the C++ in a neural network, because I have a bit of a surprise for you, as I said. And as I said at the start, for anyone who missed it, this video today, this live stream, should be called Game Engine and Game Engine. And again, as usual, the second Game Engine is the one we've been working on previously. Interestingly enough, Ade, I was actually reading over his notes on it and listening to his vlog on it last night, because I ran into an issue. And I thought I was being smart about something, and I wasn't being. So it's really, really funny. I was going over his stuff. Like, by the way, if anyone who doesn't know, Cherno is probably, I say probably, in my opinion, he is the best C++ programmer on YouTube doing videos at mass like that. His content is wonderful. If you're here, you probably know who the Cherno is, so you don't need me to shout him out. But I will say I have read over some of his documentation for his renderer. It looks like at the end he uses a row major approach, which is... Here's the weird part. When I program, I like row major approach. When I'm discussing matrices, I always think in column major approach. But because OpenGL is column major, his solution for something I'm dealing with, because he's working in row major, which, again, in my opinion, when you're programming, is the better choice, is not... It's making my head go, I can't work out where the hell these indices are. I have looked at his stuff just to see if I have made some mistakes in my own understanding of the OpenGL stuff, because he uses OpenGL. I can't use his approach exactly. Now, that said, clearly what I'm now indicating is the surprise is not Parks and Recreation. Please go away, Netflix. I've been working on an engine. And for anyone who doesn't know, I started this. This is 2 days worth of work on the engine, or 3 days worth of work. I started this earlier this week with some people off the server, and I'm trying to find my Trello for it. There it is. And here is our Trello. So we created our vector class, which in our case, let me just pop open our vector class, stores our vec3, as you can see. If I go down, it has our vec4. And our vec2. So we have our vector. Now, I want to make an edit to this today. We have our transform. So we have our translation, rotation, scale, which are just vec3s. It's actually a bug in this. Not a bug, it's a rounding thing that I want to approach and take care of. I am currently working on our matrix. I was trying to think of how to explain what this was to myself as I was working on it, or how to explain it to other people, not to myself. I am actually going to make some changes to this. Also, I'm going to be adding in my math on this one is wrong. I did the math wrong, I think. But I'm going to follow what OpenGL does and not be witty and do it... I'm actually going to use the math to do it instead of other things, instead of just putting the direct indice in. What else do we have? We have our math library, which most of you have probably seen my version of my math library before. So our math library is... I just opened up Matrix again. Math utils. Is this. So we start with a structure, and in our structure... Sorry, I realize the Trello is now blocking my stuff. So in our structure, this is our new pseudo random number generator. As you can see, we're using XO Shiro 256 plus. So this is one of the adaptations of the XOR shift approach. Sorry, I also didn't have lunch today. And in here, we have a way to set our seed. So we can override it and have a test seed so we can make sure that it's working correctly, which I can show you that in a bit. We have our shuffle table, our result, our seed. Yes, I'm using a Boolean flag, but that is literally just for debugging purposes. And our max rand. For anything that's a member, you might notice my convention is to use underscore. I know people do underscores at the end and then do M, or M underscore then the name. There's different ways. But our team agreed upon these conventions here. So, we're going to have is valid. That also should say structures, because structures... except for this one, should start with an S, and other ones, I think I actually do have that somewhere in here. Sorry, I'm trying to find where that is in our style guide. Oh yeah, no, except for structures, there might be problematic. Oh yeah, no, that's when we're actually calling it up. So like when we call up a transform, we don't call up, S transform, it's just transform. Yeah, so let me just put that back into the correct window so I'm not covering the chat still. So yeah, we have that, which we can, get a seed. We can call up our seed generator, and we have overloads for the different types. So we have overloads for our unsigned integers, our int, our doubles, our floats. I'm not sure why I did all the unsigned ones, to be fair. I just got a little overzealous with the copy and paste, I think. And yes, I realize there are other int types I could have included in being overzealous. So what we do is we call up this get next shuffle, which is declared here, and it's asking for a seed. So we pass in our seed generator, and we just... Okay, I'm just taking my phone out really quickly and just double check that my neighbor's okay, because I swear I just heard him scream. Or her scream, not the guy neighbor. Him out here from the front. Oh, I did not mean to hit... Sorry, when I picked up my phone, I knocked my glasses. I knocked my spectacles, which sounded, sorry about hitting the mic, over onto my keyboard. Okay, so what seed generator does is it uses a distribution. Now, I realize that this probably isn't the most optimal way to get our random seed. In fact, actually, the XOR Xshiro 56 or 256 plus approach actually has a recommended generator to use. I just went with this. So that should be distribution of random numbers. We pick from there a seed. The next shuffle literally is just our shuffle table in the XOR shift pattern. Sorry, not the XOR shift, because this is the adaptation of it, but yeah. And you can see we're just shifting things over. Now, this is a bit different. In their version, I don't think they assign anything here, actually. And the reason for that is they use what's already randomly stored there, I think, or their way they done their seed generator, put something in there, but because I've taken a slightly different approach, I'm passing in the seed at this point. And then it returns it. Of course, we also then have our rules inline function here. Now, I probably should make these inline, but yeah. So that's our random number generator. We have our wrappers from C Math. And in this case, just to make life a little bit easier, if we're using doubles, floats, or any of the overrides that I want to install today, we are using templates. And I'll talk about what those overrides are in a bit. The thing that popped up actually is a demonstration of one of the errors we're running into. So these are the C++ wrappers. We can ignore them, or C Math wrappers. So we have, let me just actually make this full screen instead of having it split across. So I like being able to see my headers as I'm working on my implementation files. And I will organize this all up properly later on. Why is properties open? I don't want that open. Okay. So we have a clamp function, which again takes in a type, and we just clamp it between two values. Likewise with get ratio. Now I probably should do this as a pointer now that I'm looking at it. We're just getting the ratio between the values. And again, we have a type where we're looking for a minimum and an overload where we don't have a minimum. All we're doing here is just looking for, we're assuming the minimum is 0. Okay. Not sure why. Oh, it's the ratio. I really shouldn't say assumed value there. I put my comment in the wrong spot. Let me just get rid of that. And then at the end here, I'm just going to append assumes the minimum is 0. Right, I'm not sure why I did in these ones. That doesn't follow our convention. Let me just make a quick to-do for that. I'm not going to do that on stream. Okay. So then we have this normalized to range. Now, in Unreal, this is the map to clamped range or map to range clamped. To me, it's a ratio being put on to being normalized. From a mathematical point of view, that is what we're doing here. So what we're doing is we're getting the ratio. We are then turning the ratio into a percentage. And then we are getting the ratio of that, which is normalizing it to our normal there. Hang on one second. Honestly, I probably could just use the get percentage up here instead of the interior get ratio. But actually, no, I couldn't, because the normal max is what we have to use here for this to work. Whereas this would actually just, if we use the get ratio, it would be value, min, max, max again. So we need the two different types. That's why I didn't actually use the get ratio, get percentage. Again, we have another overload for that where we don't have a min, where again, we're assuming it to be 0. Hey, let's say you named it right there. Normalized to range, what's this one? And this one we actually could... Huh. I wrote the same function twice. Okay, that's what you do now as well. Are they actually the same? Just really quickly. Return get ratio, get ratio, value, min, max, max, normal max, min. Why is this longer somehow? Get ratio, value, min, max, normal max. Oh, it isn't longer. Normal min. Oh, that's the difference. There is a difference. Sorry. Technically, this is normalizing the data to a range. This is normalizing the ratio to the range. Wow. That is a very minute mathematical difference. Vastly different numbers, clearly, and I'm not entirely sure where you'd use one over the other in a game, but hey. Value sign just returns a -1 or 1 based on the value of the symbol of the number, where 0 is assumed to be positive. Check is even, and is the simpler modular check there. And we're using our f wrapper or f mod there, but that's the wrapper version, so we're calling up to this one. Funny part was I actually did all this, and then I did the wrappers, and I went, I have to go back and fix all of this. Equals, this is really meant for our float types and our doubles, where we just want to use some precision a little bit faster. Now, because we have lots of precision here, we have the standard fixed to that, which we use epsilon or k epsilon, or I've seen other names for it. I'm calling it tolerance just to be easier to read, where we check, is this less than our accepted tolerance? So it has to be a value somewhere near 0, and I picked a very, you know what, they're pretty sure there's a hilarious macro in C++ for this. I just want to double check something, because I can't remember what the sizes of it are. So C++, let me just bring this over to the window so you can see what I'm searching. C++, that's not what I want. C++, macro for really small number. I think there's one below this I always forget about, and I just don't remember the size there. Really? Great, now I have Stranger Things going through my head. I want, oops, sorry, hit caps lock. And the E issue returns. I just want the constants. Thank you. I always forget this macro because I so rarely use it. And it also might be a Unreal one. I think it is an Unreal thing, and I'm just used to it from Unreal. I can never remember. This is the annoying part. Like, I sometimes forget what's Unreal based and what's C++ based, and this could be C++ based, and I'm just not remembering correctly. Like, there is all the chance of that. Also, I forgot to turn the music back on, so we're putting the music back on. Right, so we have that version of it. This is meant for floats and doubles and things like that. wrote floats here because I wrote a double version. I went, oh yeah, I can just make a template class version of it and do it this way. Now, that doesn't work for our vectors. So for our vectors, we have an overload that will do is equal. So we have it somewhere in here. There it is. And all we're doing there is literally the check that we have a normal check each bit of it. In the nearly equal, what we're doing is we're going to pass this over to this version of it, because this is vec2. Actually, I like how these actually call down the line technically. Sorry, not technically. This one calls down the line. So this calls up this, and we pass in the x and value from each of the two vec2s are passing in, and the y's with a tolerance. Same happens for the vec3 and the vec4. It just calls us up. Now this one, our transform, is a bit different. Our transform actually calls up the is nearly equal vec3 one here, which then calls up this. Now there is a bit of a problem with this comparison, and I found there's precision issues, which I want to talk about later. We have nearly 0, which is literally just the is equal bit here. Well, actually, it's this one here, without a without any math. We're just checking how close to the 0 that is. Sorry, I had a moment where I was like, should I be subtracting 0 from this? What? Yeah, again, I wrote a different version of it. That's why I said floats here. I did a template class at the end. We then have some math stuff where we get the whole and remainder. Now, in this case, we actually are getting the remainder. So 2 divided by 5 is 2 remainder 1. If we make that into a decimal, that is 2.5. So we have that version here where we're getting out the decimal. Now, if you notice that we're passing in this thing called out, and down here out and out. Well, it's to have a sort of like to return type approach. So we're going to pass in a integer that we're going to store this data in. So we're taking in a reference to it. Likewise here, we're doing the same, except for this time we're actually getting the decimal remainder. So again, 5 divided by 2, 2 goes into 5 2 times. 4 minus 5 is 1, thus our remainder 1 here. That remainder 1 over 2 becomes 0.5. This is what we're doing down here. And we store that there. We then have round to nearest, which is just literally taking it to round at 0.5 upwards and under 0.5 downwards. Here we have round down in all cases and round up in all cases. We have our inverse square root here. And then we have our random number in ranges. So these are just not overload. These are just ways to call the get rand function up in different approaches. So we have, in range of different types and different returns. So we have a lot of those. Get random double, just literally returns a double. We use this for our Boolean rands down below. Likewise here we have that. So I found some weirdness. Like in some cases I do want it to be less than 1. In fact, actually this is the version we call down in the bool section, where we want to have a value that's less than 1 and we don't want to include 1. I could have it include 1, but what I use it for I don't. So yeah, no. Again, we have random float, so it's random double, random float, and then the same idea. Then we create distinct sets. So sets are distinct by their nature. You can't have elements that are the same in a set. So this takes a random number based on, it generates random numbers based on a number of amounts and puts those random numbers into separate sets, ensuring that any random number that's the same number. So they get, say, 2 13s, they can't be in the same set. They'll be in 2 different sets that are being returned. And then it's the same, so that's ints, then we have doubles and floats, and then we have random bools where we just have a 50% chance. So that's less than 1, where we have a probability where you have to enter a value less than 1, but greater than 0. And then we have get random bool where you can enter a proportion. These two are really doing the same thing, but this one's actually kind of clamping you so you can't put a number too large in like you might hear. I'm almost tempted to actually have an overload in here, or not an overload, an extra parameter that will be used as an argument to go, hey, if someone's probability is greater than 1, actually it'd be not an argument, it'd be in here, probability is greater than 1, call this up, and just give them something between 0 and whatever number they put in here for their probability. Actually, no, that wouldn't work, never mind. Ignore what I just said. We have an imprecise lerp, and then we have our lerp here. Now, again, this literally just came from Wikipedia, the math for this one. And then we have our math for 2 radians and 2 degrees. I was given this by, well, I mean, it's a formula I've known for a while, but I was given this method of doing the cast of floating here by one of the people working on the team. So that is our math class. Wow, we're still in the introduction because we've done so much in 3 days. At least I feel like we've done so much. Really quickly, we have a math core, which is just a header for all our math class files or classes, and that way we don't have to call up the various headers. We can just call up the core. I'm not going to do that today. We're going to create a engine header though, or no, we're not. So yeah, that's where we're at. Yeah, I'm actually starting to work on the graphics and the renderer. I just been having some brain farts with that stuff. So I wanted to today, I have a list of things I want to get through, so I'm gonna just get Notepad open. Today, what I want to do is get the Notepad onto the correct screen. And code-wise, what I want to tackle in this is okay, so I want to work on the matrix. Let's start with that because I know I have a lot I want to do in there. I want to redo my current implementation of the indices to match OpenGL more closely, and stop trying to be clever. It hurts you when you debug. So that's a note to myself. I want to fix the 5-argument approach to perspective. I want to add in the 7-argument approach to perspective. I want to add the weak perspective approach. And I want to, ensure that my orthographic view is R and not the complement to R, if it is. Okay, and 2, make a complement to R. There's something else in there that I was thinking of. Oh, we want to make a complement to perspective as well. Add I'm just gonna call it P for now. Oh, that reminds me, I made a mistake in one of my notes, or one of the comments. Fix comments to mention correct GL functions. Sorry, I am kind of mocking myself. I think I made one up by accident or said something that wasn't true. Oh yeah. Float issue. Add float library. Test library. So that's what we're gonna do today. We're gonna do those elements. So, right, what I'm gonna do is I'm gonna leave main open. I don't need math core anymore. What have I done in here that was edited? Sorry, not here. Oh, I fixed the typo on that. I need matrices open, and this is what I said when I'm trying to be witty is not a good way to do it. And you can see I have different styles and different approaches listed here. We're gonna go back and update this. Actually, I want to change my constructors too. There it is. Fix up constructor. Okay, that's another thing we're gonna do in the matrix. Transform That'll be a part of our test later, so we can get rid of that. I don't need the vector header. I don't need the vector class file. I said that backwards. What changes did I make in here? Oh, I made the comment and then deleted the comment and then put it to doing. Okay. So yeah, we don't need that. So yeah, we need our matrix, and I think that's perspective only. No, that's orthographic too. So just because I know I'm going to want to do things differently than I've done them. Sorry, I need to be, okay. Let me just get the things I need for today open and on the window, just so I have them in the right spot. Sorry, this is all related to the float stuff. This is a library I want to download later on, just to see if this helps with something I'm running into. That is not what I'm looking for. Don't know if I have that left open. Oh, that was me trying to figure out if I could overload a float a particular way. That's what that search was from earlier. Sorry, I'm just making sure I have the materials I want. That is completely unrelated. That's neural net stuff. What's this a picture of? Oh, motorcycles. Okay. Sorry, like I said, I'm just not organized today. This is the OpenGL stuff that I'm reading through. So that's the GL programming. That is not what I wanted. Actually, I do want that. I want the article attached to that, though. So that's the article that came from, I think. I think that's this one, 24? That's 23. Oh, that's perspective. That's orthographic. Yeah, it's 20. Sorry. Reading on just extended precision and memory just because I wanted to do something again with floats and I was running into issues. Sorry, I have a lot of random open. Okay, so that's what I wanted. Sorry, just give me another second. I have so many tabs open that it isn't funny. Like, it's terrifying a little bit looking at my screen. Okay. So many things I don't need. Stack Overflow relating to the issue I was complaining about. The Stack Overflow that made me less anxious about what I was doing, but didn't give me the answer to my question. Cool. All right. So, all right. So I'm just getting OBS back up on my screen. And what we're going to do is we're going to start with just declaring the things that I want to do. So we're going to declare this bit, and then we'll go through and do the rest as we go through. So first, actually, I'm going to fix up the mistake in this. Let me just get the names of the functions up here. So this is actually the GLU perspective approach. That's correct. This is not the Frostrum approach. This is the GL ortho approach. Now, the GL Frostrum, however you say that. So the approach that I had a name for is a perspective approach, and it's the 7-argument approach. So we're going to do static matrix perspective. So we're just going to overload this, and I hope I can overload this. We'll find out the fun way. And it's float left, float right. I am just making sure it's in the same order. Bottom, top, near, far. Yeah, it is. Float bottom, float top, float near, and and float far. Okay. Then we're gonna do set complement of perspective projection using, again, the G-Flatstrom approach. And it's taking in the same exact argument. So we'll just copy this for now. And we're just going to name this complement. Okay, and then what else do we have on the list for that one? So this is the declaration for, I know the math in there is wrong, that's implementation. So on CPP, both, that's one we've done, and we haven't done this one, this week perspective. So we'll do week perspective. Give me a second. I'm trying to find my notes on week perspective. Okay, sorry. I need 3 arguments, but I have the math for it. I'm just not entirely sure what this one's storing. But yeah. Set week perspective. Give me 1 second, just because I can work out what it's going to be based on the letters here. So, I'm pretty sure that is, sorry, static matrix week perspective. And I'm pretty sure that is float top float right and float near, if I'm understanding what I'm reading correctly. God, I've never done this before. Like, I could be way wrong about this. Okay. Let me just bring this back on the screen. Okay, that's both, so we have that set up. This is class. This is done. And this is both. Okay, so we've started to do that. Right. So next, what I'm gonna do is just looking at my things here. Okay, let's just look at how badly I did things. So I'm pretty sure what I've done here is I've actually done the complement, and that this is the actual these are the actual values I want. And then here's me being clever and actually putting in the indices. Instead of doing what OpenGL does in their documentation of going, yeah. By the way, I have been looking at other engines. Like, I was looking at Unreal's approach to this, and actually I have it open. Sorry, that was the wrong one. There it is. So I was looking at how they've done things. Like, they actually did a proper 2x2 matrix. So again, we have our 16 values, and yeah. So we could do it that way. That's just not how the OpenGL documentation's written, so that's not why we're doing it that way. If I had worked with OpenGL a bit more than I've currently done, I might take a stab at doing something like that. God knows that's what I'm doing with the neural net stuff. Like, you guys saw me converting between various things. Oh, that reminds me, I need to very quickly do something on Discord before I forget, relevant to this topic. I need to reopen a thread. I can't reopen it. Sorry, so I just said I want feedback on this thing because I Give me 1 second. Sorry, it's a bit windier than I expected, thus me leaning over to close the window. So, just going to turn off the camera for a minute so I can do something. For those of you know who me, you know what I'm doing. And why the window mattered. Okay, so. Let me just get this document back up onto my other window. So 2 over right minus left is correct. And this is sorry, it's 0 plus 0 times 4. Okay, at least I think that's right. I hope that's right. All right, so this, I wrote a comment so I knew what order crap was in. Why is there columns, X, or rows? Is that right? I think that's right. I'm now doubting myself. I'm doubting myself a lot now. Oh, I did it down here. That's when I actually copied this directly from the documentation off of OpenGL. And I misread the documentation for this part, which is why I'm struggling now. So yeah, this should be, well, regardless, it's 1 plus 1 times 4, because it's 5. For those of you who don't know what I'm doing when I'm doing that, let me just get the document back up on screen for you. So we get the image version of it. So that's 0 plus 0 times 4 is 0. 1, 2, 3, 4, 5. 1 times 4 is 4 plus 1. 6, 7, 8, 9, 10. So it's going to be, I need to make sure I get them in the right order, or otherwise things might go weird. Okay, it's in the third column, so it's going to be 2 anyway. So it's going to be 2 plus 2 times 4, because 8 plus 2. And then after that we have 12. Hang on, let me just bring this back over. So that's 10, 11, 12, 13, 14. Yeah, because they're restoring our translations. Right, so 12 is the first one, so it's going to be 0 and 3. I'm just going to do 0 and 3 and hope I have it in the right order. 13 then would be 1 plus 3 times 4, so 12, 13. And this should be 2 plus 3 times 4. All right. Now let's actually go through these. So I'm just actually gonna hover that there, kind of. So you can see what I'm doing. There we go. So, all right, 2 over right minus left. And again, for those who wants to know where that document came from, it's the OpenGL Programming Red Appendix F. 2 over top minus bottom. Negative 2 over far minus near. And then we have right plus left with right minus left here. I guess this is literally, this is the same idea. Now, why is that one, why do I have try not as a negative here? Because that's coming from neither of the of these. They're both negative 2s. Okay, then we have right plus left over right minus left. I already did that one. Top plus bottom over top minus bottom. Far plus near over far minus near. Yep, that's right. You know, the entire table is actually 0. So what we're going to do instead here is we are going to just set that final element. And that is, so that's going to be 3. So 0, 1, 2, 3. So it's 3 plus 3 times 4 is equal to 1. Oh, not, wrong key there. All right, so that is our 1. I also don't need to put a number here. That makes it diagonal. You should. Okay. Result must have. Okay, so I guess I do need a number there. We will make it diagonal. Everything else will be 0. So what's happening here is we're using this constructor, which is going to make 0, 5, 10, and 15 all into 1s. Okay, whatever. All right, while we're here, let's also clean up this stuff. So this is 0 plus 0 times 4. This is 1 plus 1 times 4. This is 2 plus 2 times 4. 13, based on what we did earlier, is 1 plus 3 times 4. And then this is 14, so that is 2 plus 3 times 4. Okay. Now let's make sure that the numbers line up correctly and that I have it right. Sorry, I just opened Discord, but I lost track of my windows. Okay, there we go. So let's go back here, open that one in the new window. We have this is the other approach. Okay. I don't have the documentation I used for the this approach. So I'm assuming I did this right. Yeah. I also realized I have my camera off still. So yeah, I don't know. I don't know. I'm just gonna scroll through this document really quickly, make sure. By the way, for those who don't know why we're using the numbers we're using from the matrix, just because I'm going to bring this over. As I said in my documentation, up here, that's translation. Actually, I probably should add in scale as well. Scale stored in 0, 5, 10, 15. So that's the diagonal. That's what there is. And rotation is stored because rotation is going to impact on translation in those elements. All right, so let me just make a quick note of that as well. Rotation stored in So that is 2, 3, 4, 7. Wait, hang on. Okay, that's not right. I'm not entirely sure how to explain what rotation stored in this based on this, because rotation relates to a lot of them, it seems. So like if we keep going down, we can see it's here. It's basically everything except for the corners for scale. Oh, sorry, for translation. But it does affect the rotation, like I said. So actually can do rotation involved with 0, 1, 2, 4, 5, 6, 4, 5, 6, 8, 9, and 10. Okay. Right. Let's just back over. Let's go down further here. Let's grab the Flostrom approach over this. And yeah, that's actually my notes on the different approaches. We don't need those anymore now that I've decided, hey, we're going to actually use different approaches or have overloads for the other approaches. So it's going to be matrix, make sure to append it to the correct spot. All right. And for this one, what we're doing is all right. I'm gonna make a matrix called result. Wow, I can't type today. For now, let's actually put this as 0. Just I want to double check my constructors really quickly and my options here. Yeah, we'll just do 0. All right, and then what we're gonna do is result dot elements at 0 plus 0 times 4. In fact, actually, I think it's the same as what's down here. I just don't trust what I've done previously. And this is going to be 2 times near over right minus left. Okay. Then we do, I'm just going to copy this. Okay. So that's 0, 1, 2, 3, 4, 5. So that is 1 plus 1. And that is 2 over times near over top minus bottom. So am I reading the right one? Oh yeah, it's times near. That's a difference. Okay. We're yeah, I see. Okay, so that is the right one. So we're literally just following what's the orthographic a bit here. Okay, so I'm just gonna take this because I had the lurking suspicion that the next one's gonna be 10. I don't think it is actually, now that I've just looked over in the other window. Let me just do this really quickly. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's 0. And, oh, hello. Not being in the correct case. Likewise, let's fix you up. Okay. So, that's 8, and that is going to be right plus left Sorry, I'm just looking, it's the same thing at the bottom there. Right plus left divided by right, minus left. Right, and then we have the element right after. So that is 11. I'm just gonna double check that. 0, 1, 2, 3, 5, 6, 7, 8. 8. Did I say 11? I meant to say 9. 9. And then we also are going to have 10 as well. So I will just very quickly toss the 10 one in there before I forget. And it's actually this down here. Therefore, it's not negative. It's top over bottom. Or top plus bottom over top minus bottom. Just going to double check the orthographic really quickly because I'm far plus near divided by far minus near. I did the orthographic one. Okay, we're going to go through that one more time in a moment. So, that is top plus bottom, top minus bottom. And then in element 10, it is negative far plus near. And because because that's supposed to be negative, just going to do it that way. Rather safe than sorry. Over far minus near. And then in a final element, I'm just going to cheat a bit and copy that out. It is, sorry, just make sure that's right. I skipped 1. And that should be 2 plus 3 there. And that's negative 1. Okay. Also, I'm just going to keep the convention up of what I'm doing here. There we go. Okay, so that is negative 2. Oh, this is an interesting one. 2 times far times near over far minus near. And again, because that's a negative around that, I'm just going to be anal retentive and do that. Make my life a little bit easier. All right, so just going to bring this onto the screen, make sure I'm not making any mistakes again. And I'm actually going to close these both out so I know I'm opening the right one. And we have our perspective here. So let's do perspective. So 2 times near right minus left. 2 times near right minus left. Position 0. Position 5. That's 5. 2 times near over top minus bottom. That's correct. 6, 7, 8. 8. Oh, thank you. Thank you, Noxy. Okay, so 2n, so 2 times near over top minus bottom. 8 is right plus left. Right plus left. 8, right minus left. Right minus left. 9. 9 is top plus bottom. Bottom, top minus bottom. Top plus bottom. Top minus bottom. 10 is negative far plus near divided by far minus near. Negative far plus near divided by far minus near. Welcome in, by the way. How are you doing? 11 is negative 1. 0, 0, and then 14. So 12, 13, 14 is negative 2 far times near. Far times near over near minus far. All right, that's right. And do I have weak perspective next or complement next? I have complement next. So let's do complement since it's the same argument. And get rid of the static. And this will be matrix. Now, because I'm using namespaces, the refactoring tool does not seem to work correctly for me. It just gives me an error screaming, I can't make this, I can't make this. Yeah. So, yeah, take from that what you will. And by the way, yes, I am munching on something. Right. I really kind of want to see if I can get away. Oh, we skipped one very important thing. We need to return result. Okay. For this one, I kind of want to see if I can get away with just doing result. I'm an idiot. Yeah, we're doing it that way. Result elements 3 plus 3 times 4 is equal to 1. Okay. That's why that wasn't working. And in fact, then we're going to do the same thing here. We're going to just ensure that that element is 0. Okay. I can't believe I did that and didn't catch my mistake. I'm alive and kicking, I think. Potentially. Maybe. I don't know. I think I'm alive. I think I'm kicking. But I haven't been told yet, so let me know. Oh, God. Sorry, I'm having a slight problem with OBS. Like, the chat vanished on me, and I'm trying to get it to come back. And then when I bring it back, it then just respawns in the wrong spot, so I can't see it. I have it back up now, by the way. And now I need to get back to... Why do I have, like, 3 copies of that window open? Oh, that's not something else. Okay. Just... Yeah. Okay. So we're going to do the complement now. Ooh, that's not complement. Oh, what's the name for that? Inverse. It's the inverse. Sorry, I read that as R apostrophe, which is R, which would be complement. Inverse. Inversee. Oh, also, probably should do this as well before I forget, even though I noted it as being done. Okay, so this sets inverse of okay, there we go. Oh, result. Return result. Okay. Cool. By the way, you can't tell I have my head angled this way. The microphone is covering, literally from my point of view from where I'm sitting, half of the word perspective complement. I say half the word because one eye can see all the words in it and the other one can only see complement. So I'm leaning to the side to look past the microphone. Right. So let me get that table back up on my screen. And it is, we're going to start with this element, the first element, element 0. And that part remains the same, actually. It's now 2. Give me 1 second. Okay. Okay, it's... Oh, sorry. I'm reading the wrong side of the thing. I was very confused and somehow also just misread what I was... Even the wrong side that I was reading, I misread. So it's actually 2n over right minus left. It's the inverse. Duh. So, you know what we could do again is just copy this. Oh, man, that's why you giving me that error, isn't it? Thanks for saying that out loud, Zach, that it's the inverse, because otherwise I would have been, why is there an error? Okay, so what we're doing instead is right minus left divided by 2 times near. I mean, you're doing math that I don't understand, like an eldritch god, so I would say alive and kicking. Well, the funny part is, your understanding and my understanding of this math is probably the same level as H.P. Lovecraft's understanding of non-Euclidean geometry was, which is to say non-existent. the scale is so small that it doesn't matter. Sorry. I couldn't resist doing that. All right. So the next index is 5. So we can just take this one as well. And again, it's literally the inverse of what's here. So we're just going to move that to this side. Also, I want my spaces. Yo, come on. You are giving me out everything else. Then we're going to do 5, 6, 7, 8, 9, 10, 11. So that one. And this one is... Okay. Not one that we did previously. Cool. So this is going to be negative far minus near over 2 times... Sorry, every time I type in a new number like that, I'm seeing where I forgot to do my convention. 2 times far times near. And I forgot a bracket up here. Okay. Then it is 12, 13, 14, 15. So it's all the last ones. So result dot elements, and then it's 0 plus 3 times 4, so 12. I'm just gonna do this really quickly. 12, 13, 14, 15. So that would be 12, 13, 14, 15. Right. Let's just knock out the easiest ones right away, which is this one here, number 14, and that's just -1. I think. Yeah, that's a 1. It's not negative left. I had a moment there where I was like, yeah. Okay, and then, so element 12 is right plus left divided by 2 times near. Okay. This is top plus bottom divided by 2 times near. Sorry, I really do like having my spaces for some reason. Okay. There we go. This is -1, and this is far plus near divided by 2 times far times near. Okay. Fear. Right. There we go. Let's check both of these one more time, because... Also, I'm just going to turn my camera off for just 1 second while I chew on something, because I'm hungry. I haven't had lunch as I said to the stuff going on today. Alright, sorry for hearing the tinfoil crinkle, probably. I know I've checked this already, but rather be safe than sorry. Sorry if this is boring. Okay, that one's right. Okay. Right plus left. Oh, okay, I misread that. Top plus bottom over 2n. Top plus bottom over 2n. Negative 1. Negative 1. That was one I thought was an L for half a second. Far plus near over 2. Yep, okay, that's right. Cool. That is our perspective, or inverse perspective done. Now let's do our weak perspective. All right, again, get rid of the static. Also, I need to get used to doing this to become faster. I keep forgetting to do that, and it just, yeah. All right, sorry, I'm trying to find my notes on weak perspective now. That's on choices between the different things out there. Okay, whatever, go away. Okay, so weak perspective. Weak perspective is, we actually do need a diagonal for this one. So we actually, and I'm not joking, we do actually need the diagonal. Because we're only going to change one of the values on the diagonal. They all are going to be 1 otherwise. Okay, so let's make sure I return result, because I keep forgetting to do that. Would love if you started to autocorrect that stuff like you used to. So index 0, we've already done. It's diagonal. You know what? This is just gonna be, I just need this, okay? That's the reason I wrote this thing, was so I could do stuff like this. All right, so that's 0. Index 5 is set there, that's 1. So index 8 is the first one we want to tackle. So that's result elements, and 8 is 2 plus 2 times 4 is equal to negative right divided by near. I think I'm reading that math right. Result dot elements I can do math. At element 9 is negative top divided by hang on, I need to reorder this. That's why I'm getting myself confused. I need to do this in the order in which it's actually on this thing. I'm gonna go, okay, so, sorry, my contact's falling out, so I'm readjusting it. I hate contacts. They're burning my eye right now. All right, I might kill the camera. Take it out. And put, oh no, never mind. Got back into spot. Okay. No, that's not right. Okay, so okay, that is definitely near. I did the math wrong, sorry. Let me just find a better table for this. So I'm just Googling weak perspective matrix. Come on, Wikipedia. Huh. I didn't know those had different names, those separate perspectives. Sorry, I'm just literally reading through some stuff on this. Isometric projections ruin optical illusions. Cool. There we go. So, the weak perspective projection uses the same principle of an orthographic projection, but requires a scaling factor to be specified, thus ensuring that closer objects appear bigger in the projection and vice versa. It can be seen as a hybrid between orthographic and perspective projective. I'm reading from Wikipedia, by the way. And described either as a perspective projection with individual point depth Zi replaced by the average constant depth Zav, or simply as an orthographic projection plus a scaling. The weak perspective model thus approximates perspective projection while using a simpler model similar to the pure unscaled orthographic perspective. It is a reasonable approximation when the depth of an object along the line of sight is small compared to the distance from the camera and the field of view is small. With these conditions, it can be assumed that all points on a 3D object are the same distance, Z average, from the camera without significant errors in projection compared to the full perspective model. Okay, so right, we need to have a focal distance included in that as well for this to work. Let me just get that Wikipedia article back open. Really was all right. The math on that is confusing from Wikipedia, so we won't use the Wikipedia version of it. All right, let's go to the Facebook for Nerds. And if you don't know what Facebook for Nerds is, it's called ResearchGate. Am I signed into my ResearchGate account? Oh no, I'm not. All right, Roland, what do you have for us? Ooh, Roland, you have done a lot of publications. Not recently, though. Not in the last couple of years. What's in here? Huh. Interesting. Okay, not what I'm looking for, but definitely something I want to read in my free time. That is research related. Cool. Okay, stack Overflow. Oh, that's actually where I found the Wikipedia article. Springer, let's see what you got. You're gonna ask me for a lot of money for this, aren't you? Oh no, you're actually going to just show me the preview. Are you a dictionary? You're a dictionary. Okay. Not useful. Sorry, again, just trying to find a better explanation for the math, because what I'm reading is really confusing to me. ResearchGate. Interesting. Also, oh no, also the name world, but not the same one. No, the name's different. Okay, I don't need to see the non-Euclidean geometry, like the math behind it. Yeah, I've already read that one. Let's see what this university has. The geometry of perspective projection, pinhole camera, and perspective algorithm. This is the simplest imaging device and however captures accurately the geometry of perspective projection. The ray of light enter the camera infinitesimally small aperture. Wow, I could say the word infinitesimally. The intersection of light rays with the image plane from the center of the plane from the image of the object. Such a mapping of the 3 dimensions onto 2 dimensions is called a perspective projection. Okay. Oh, there actually is a complement, by the way. Using matrix notation. Oh, this actually might... Okay, hang on. So this is what I'm reading. This actually might explain what this person's trying to do with their stuff. Nope, it doesn't. Cool. All right. Sorry, I'm just really getting distracted by this, and since I have it on screen, I'm not going to read it out. Yeah. Weak perspective. There we go. Okay. So let's go through this. Perspective projection is a non-linear transformation. Yeah, I already knew that part, funnily enough. That's why we have the cosine math and all the tangent stuff. We can approximate perspective by scaled orthographic projective, as we read from Wikipedia. The object lies close to the optical axis. This is the if conditions. The object's dimensions are small compared to the average distance from the z average, or Z-av, as I said earlier, or something when I was reading it from Wiki, because I used underscore notation instead of a proper bar like that from the camera. So sigma is less than the average of z divided by 20, or z bar divided by 20. Weak perspective projection equation then is x is equal to xf over z, which is approximate to xf over z. A is approximately equal to A. I don't get that. The term... okay, so it's actually X function. Duh, should have read that. The term function... oh, I see. I misread that. It is the function of... X, it's not a function, it's whatever it is. X over Z is approximate to X over Z bar. There's a little bar there. I'm blind. The term is a scale factor. Now every point is scaled by the same factor, which is the average of Z. Okay, so there's that diagonal bit I was trying to do. Oh, I said we're going to set it to 1. So I'm just looking for something in here just to make sure I've understood something in the math. Okay, that was actually useful and just helping me understand the material a bit better, but not what I need. I want to see how this is done in OpenGL. Okay, I'm keep getting the same Stack Exchange on Google like 3 times now. Literally the same one. Sorry, I'm just going to check something really quickly on this person just to make sure that I'm looking at the right thing. Okay. And that's -1. This is not that. Okay, so I already knew that. Sorry, I'm just reading an article, so I'm going to read it to you. What similarities does Matrix have with the Matrix we studied in the previous chapter? None, because we haven't read the previous chapter. First, it is important to remember that matrices in OpenGL are defined using column major order as opposed to row major order, as I mentioned at the start of the stream. In the lesson on geometry, we have explained that to go from one order to the other, we can simply transpose the matrix. You know, given what we're actually doing, yeah, we're going to do that. In fact, actually, I think these might be the same at the end of the day. It's how we transpose it. Did I write a transpose function? I thought I did. I didn't. Okay. All right. So, oh yeah, guess I should bring the new name over. Okay, so we're transposing the matrix. However, their math is not matching on to. So the math they have here, if we go to our appendices here, doesn't line up. That's different. That's the same. That's the same. That's the same. That's the same. Interesting. Okay, so I'm going to make note of that other approach. Cool. All right, let me just move that back over. This is a matrix we would be using in Sketchpad as we now use vectors. I mean, this is actually a really good article. I'm just not sure if the math is right, but the explanation so far. Okay. Huh, teapot. Oh, I have actually seen this person's code before. They use a 2x2, proper 2x2. Right, not what I'm looking for, but I want to save that article because I actually like that. I've already done that one. See, I'm getting, like, everyone has a different math for these, and, well, some of them tend to agree with the OpenGL. You know what? We're not doing weak perspective, at least not now. I will come back to that one. Also, I also will approach right here. Also, to do weak perspective. All right, let's go back to just, I'm gonna very quickly comment this out. Oh, that's not what I want to comment out. I want to comment the one below you. Because I commented out the wrong thing. I want to comment out you. There we go. And this can go away for now with a comment. I'm so glad I pasted that there. All right, and now let's double check our orthographic. Okay, so we have 2 over right minus left, 2 over top minus bottom, -2 over far minus near, right plus left, right minus left, top plus bottom, top minus bottom, far plus near, and far minus near. Cool. I just want to double check this thing really quickly. Actually, I can just do it this way. Okay, so yeah, there's a different approach for transposing orthographic. Makes sense. So let's then do that and do our transpose orthographic. I saw all those nice little notes in there. Okay, we're gonna do it here. Right, get rid of the static. This will be matrix. And it's actually all the same spots. So we're just gonna take all of this, paste that into there. And this becomes, hang on one second. Okay, nope, that guy just had math that does not match anything else I've seen. Okay, sorry, I had a moment where I was like, maybe he put the orthographic transpose in instead. No. And the he in that is the guy whose article I just had up a moment ago on screen. So it is right minus left over 2. I could have just literally copied and pasted things. Not 20. Okay. In this case, it is top minus bottom over 2. Also, again, that's going to drive me up the wall. Okay, and 5, 6, 7, 8, 9, 6, 7, 8, 9, 10. Yeah, okay. Thought it was 11, so I'm like, wait, what? Is literally, again, just the reverse. Negative 2. So that comment is really stupid because this is an additive principle. This one's kind of stupid because if this doesn't work in this order, reversing it, again, it's reciprocity. It's not going to, yeah. However, this is different. So we will do it that way. Again, that is just a stupid comment. We'll get rid of that. All right, so where was I? This one. So then it becomes right. And then instead here, we're going to do another division by 2. And then it's top plus bottom. Again, it's another division by 2. And then for this one, it is... okay. Just like what I just said, I'm going to do this just so that I'm following the order in which they've done it. It's near plus far divided by 2. And the reason I'm doing that is so when I do this in a moment, I can go right minus left over 2. Top minus bottom over 2. Far minus near over negative 2. Right plus left over 2. Top plus bottom over 2. Let's try that again. That was starting in there where I noticed that. So right plus left over 2. Top plus bottom over 2. Top plus far over 2. 1. All right, now I'm going to double check these negatives. Maybe I did screw this up where I have this if this fails. Nope, negative 2f. Okay. However, right plus left over right. Yeah, it isn't negative on that. That one isn't negative either. Nor is the final one. However, top right plus left over right minus left. Top plus bottom over top minus bottom. Far plus near over far minus near. 1. Okay. That actually seems to match. Interesting. I just messed something up along the lines then when I was copying that the other night. I knew I had, by the way. Like that's why I said today we're gonna redo this because I was certain I had messed something up. Why do I have the comment to literally do what's already there? Okay. Sorry, I did a lot of this while I was working on multiple things, so there's going to be some weirdness like that in some places. All right. So, oh, we need to fix it. Okay, hang on. We have done that one. We're skipping this. And we did that. We've done that. We've done that. Okay, so we have the fix up constructors. Oh, also, hang on. Did I do all of those before? Yeah, okay. Any inlines in here? Nope. Okay. Also, just to build really quickly, make sure we have no errors. I know we have some warnings, but... Okay. Right. I actually, while I was doing this, did find my notes. They were just... yeah, I didn't recognize it as what I was looking for. Alright, so I have a couple of different ways that I saw people doing it. And I've decided to use the tan approach. So, just to have the image here. So what this is one. Let me just start moving crap around so I can actually see the chat again. So we have 1 over field of view in the x, or field of view x, divided by 2, which is 0.5 times FOV. 1 tan, or negative 1 tan, so that's the inverse of tan, so we're in tan. The answer I was reading earlier was negative 1, wait. Yeah, inverse. Sorry, when I was reading the negative ones earlier, I was seeing apostrophes for complement. All right, so that's 0, 5. 5 is tan, or inverse of tan. Field of view y is the aspect ratio. Okay, so then it's near. I had it backwards. Ooh. This entire line is wrong. This should be... not that. Sorry, I'm just going to move this to the other window really quickly. This should be far negative. Okay, hang on. Negative far plus near over far minus near. I'm just going to try without neg in case I'm wrong. Also, I need to put my Terminator back onto this thing. And get rid of the random Terminator that I left there when I meant to delete it. Sorry, I'm double checking what I've done there. Far minus near. Oh, sorry, far plus near divided by far minus near. Yeah, that appears right. Okay. Negative 1, 12, 13, 14. 14. 2 times See, this is why I like having those spaces. Helps me tell pointers from math notations. Okay, so 2 minus near times far over far minus near. All right, so far minus near. And that's 0, not 1. So that is result dot elements. So 12, 15. Yeah, that's right. Okay. Nope. 2. It's not a function. There we go. Okay. So inverse over the field of view x, which is over the field of view y, which is including aspect ratio, far plus near, far minus near, negative, negative, -1. This should also be a negative, -2 over near, far, far, near. All right. Also, we're actually going to do this differently. I get it's the same thing. I want it to be standard all the way through. And so this is a style I'm going to be doing it in. All right. All right. Okay. And then we have the constructors. Give me 1 second to get rid of that other Chrome window. I'm just going to put it back into my collection of stuff related to this. Stuff I was working on earlier, plus the things I opened up, like the ResearchGate article that I was talking about, where I said, ooh, this isn't related, but I really want to read it. That's the Stack Overflow one that I kept saying I have multiple copies of. Just quickly build, make sure I haven't missed anything else. I have not. All right. Set elements to 0, set element to 0, set our diagonal values. Other check could be in there. Get an identity matrix. Multiply. I assume I have that in the right order, but we'll test that later. Okay. Why do I have fix up constructors in my list? Was there something I wanted to do? Okay, no idea. Constructors are good. So let me just show you something that is happening. And this is the next thing we're working on. This is the float stuff I was talking about earlier. Sorry, I'm going to move my chair because I don't like this chair and it's collapsing. It's an old chair that's really kind of crappy. So this will display its full range. This won't. This will. This won't. By the way, the reason why I have the breakpoints like that, or the writing like that, is I do 2 windows typically. So I had this off to the side, and I didn't just want to deal with the scrolling of death. So if we turn this on, we see we get our transform. So this is test 1 with its first vector for scale, its second vector 3 for rotation, and its, translation, rotation, scale. And notice we have the correct values there and there. For this one, which is these two, which are these two lines there, notice that we get truncated. We come down here, and we have this happening. We have the correct values. We add one more 0 in, and we suddenly lose the values. So I am not thoroughly impressed by that in the slightest. Also, to show you the rest of the stuff that I've been doing, if flaw. So here is our basic math utilities that we wrote. It's going to take a moment because it's going to run through, okay, so here we're clapping a value of, I can't remember what I plugged in. So our values are 50, -50, and 150. So the clamp for 50, which is between 0 and 100, is going to return 50 because it's a good value. For -50 between 0 and 100, it is 0. -50 is less than it. For over 100, so 150, we go to the 50. We then have our proportions that I showed, or ratios that I showed you earlier. We're technically proportions. So this is the regular one where we put in the mins. This is without the mins where we assume what it is and put in a max. Which can be problematic, by the way. But if it's always going to be 0, then hey, useful to have, get our percentage. And this is, just the get percentage. Unnormalized to range, or check if even. Which one is that calling up, actually? I'll look at that off stream. Our sign check, if it's even or not, and because I updated what the values were. Here is our random number generator. This number should be random. This is a seed selected over written one that we're doing. So these two should remain the same. And as you can see, throughout these, they do. But the first one and fourth one should be different. If we rerun these should be different. But these two, for now, until something happens to my computer, should always be these values. Now, you do get one weird one for some reason. I can't work out what's going on here with float. Where with floats, we end up with these two numbers. Now, again, if I rerun it, we will get these two numbers again. Now, what makes this interesting to me is, again, here we have some more random variable floats and doubles and ints and things like that, right? And in this case, every second one, it has its seed set. Notice they're all 79. All this function is doing is calling this function up. Literally all it's doing is calling this one up. But yet, for some reason here, it displays differently. Okay, there's a random double, no settings, so it's just a large number. Where max is 10, where it's less than 1. Yeah, just that's just making sure our sets worked. So notice there's no numbers that repeat within a set. Random bool with 50%. So we have just, because it's 5, it wasn't going to be an even 50%, but yeah, you can see it's there. Where we have a 10% chance, we have a false, 25% chance, false, and then for anything 50 and above, we had true. This is ratio, so we had a 10% chance here. This is a 25% chance. This is a 50% chance, interestingly enough. This is some random number chance, no idea. And this was under, this is 45%. If I've done my mental math right. So here we have showing that the whole remainder is actually storing in a value. So there we are. And that's the other version of it. And then we do the same math for rounding it down. And we repeat the process to show that it works with other values as well. And then we're doing our standard check, our 2 floats equal, our 2 floats equal, 2 floats equal. Now this is our 2 floats equal within a tolerance. Notice that this one is not equal, and it's still not equal here. But when we change the tolerance just slightly, it's nearly equal. Is this nearly equal to 0? No, as we get, because it's 1 point. But then we drop the 1 and make it a 0. Well, hey, we're really close to 0. So that's our math utilities. Our vector stuff. Also, the GLFW stuff is not ready for previewing yet. I've literally just put the includes into place. So this is a bit badly designed, but I was doing it piecemeal, so I knew how to read it at the time. So we check our vector 2s. We're setting 2 of them. So this is vector. This is our first one. This is our second one. We take the first one and we add into it some random numbers that I just randomly typed on the keyboard, and we get back, well, those random numbers because we're adding 0. And so that's make sure it does math work. We add the 2 vectors together. I noticed that since we've updated this one here, just to show you what is happening, it's it's that bit there we've just done, and there's us actually setting it. And then we create there's us. Then we do this bit here where we add our 2 vectors A and B together and get our C vector, which is this one right here. And then we reset one of them by multiplying it by 0 to see it works. And then we just do a bunch of math. That all repeats through all of these. Now notice we have these nearly equal to checks. So we have what's called more precise and less precise. That's literally just me changing the tolerance. So if we go down here, we don't override the default tolerance. Here I remove 1 decimal to override it, and that's why it's saying they're equal. Oh, sorry, I misread something for a minute. I got really confused. Like, what? Yeah, these should be the same, and these should be the same, but these two should not be. So yeah, that's what we've done so far. Now, as I was showing you earlier, sorry, do you like how I've done this? Literally, it is a while trigger. It does everything and then jumps to the next one, then the next one. Like, I needed a way to turn them on and off and have different combinations, because I had some random bugs when I was copying stuff over to do it. And when I say copying stuff over to do it, to be very clear on what I mean, most of everything that's in here, in the Vec 2, also is in the Vec 3 and the Vec 4. Well, it does lose some of the stuff in the Vec 4, but it basically everything repeats. So I was copying over, changing out the wording. What's this thing? It's probably the same thing as what's above, just a different way for me to look at it. Yeah, it is. So as I was showing you earlier, we have an issue where we're running into loss of data, right? So I've seen a few different ways of handling it, and I'm going to show you one way Epic handled it. So if we go into the core public runtime, math core public runtime, runtime core public math. That was the correct order. Again, that is runtime core public math. So the one that isn't on screen, the word runtime is a higher one. So if we go into there, we have this entire thing of floats. This is what they've done. Now, what I really want to do is find where else this is called, because everywhere else this union is set up the same exact way. Like, it's same way here. So that's their way of handling it. Now, I could go in and make my own float class, which is why you saw the weird Google search I had earlier. So I'm going to eat this tomato. You saw earlier. But I, after writing 3 vector classes, a transform class, and the matrix, well, the matrix isn't a primitive type. It is. Okay, so after writing 5 different sort of primitives, I kind of don't want to touch them unless we do a custom container class, which we are discussing. We were also discussing a custom string class. I'm leaning towards a custom string class due to serialization and replication, because when working in Unreal, I've run into issues with with how data is serialized, and just it's a nightmare. And localization stuff as well would just be easier if we had our own custom string class. I really don't want to write that one, mostly because I'd probably just copy the C++ string by accident. The standard C string. And for container classes, well, Bjorn says, to use standard vectors, so std vectors, where and when possible, instead of arrays or pointer arrays, or pointer arrays for our nested arrays. If you got really, really trippy, pointer array. Yeah, try doing the math on those. Real fun, let me tell you. Yeah, instead of doing that, he says use standard vector. Now, standard vector, well, as you know from the machine learning programming that I was doing in the past several weeks, I will always opt where I can for a vector. Now, I have been doing some research on how, and it's gonna, as you know, I ran into some issues with that where I had to convert between a pointer to a nested array and a vector, and ran into a lot of issues. But have you really done a triple nested array of characters? What are you doing, a 3D word art thing there? By the way, welcome in, Zach. Like, the only time I ever have 3D vectors like that, or arrays like that, is when I'm actually doing data visualization or some really annoying machine learning stuff. Voxel math is evil math. Down with voxels. So we could have the choice of creating our own container class that has all this overhead but has everything we need built in. Or we can create a custom container class where we're just making our own version of the standard vector. Now, definitely the string, both are really important, and I really kind of do want both. Both are going to play a major role in things. But in terms of getting something testable, I'm not sure which one I'm going to go with first, or why I would go with that one. I am going to turn my camera off just for a moment, because again, I've not had lunch. I either going to need to eat something at some point during this, which I'm not going to do, unless I just mute myself and watch me typing. No camera if that happens, by the way. But if I'm not going to have food, then I need something to curb the appetite. I also want to see if there's anything I forgot that I want to do in the matrix and for my other notes, because what you saw me type on the screen earlier was my stream notes, like, hey, what do I want to do on stream? Because I didn't have time to prep today. So, we've declared the type. I'm almost tempted to follow Epic's naming on the... No, elements makes more sense. I was going to say components, because is what they tend to call these things. All right, I wanted to have an identity matrix. Got that. I wanted to multiply. Have that, because multiplying these were hard. Have that. Have multiple versions of perspective like I wanted. Have the transpose. Could not figure out the math for the weak perspective, as you guys saw me reading or heard me reading articles out loud. Have my orthographic. Have my orthographic transpose. Have my translation. Have my rotation. Couldn't get this to work either. Have my scale. That's everything I wanted to do for this for now. No, I'm going to come back to this and do more, which is why I started putting these in, because I'm definitely going to... I've never worked with OpenGL like this, so... I've worked with OpenGL, never set up my own renderer for it, so... Haha, nah, the only time I deal with char triple pointer is when I pass a regular char double pointer by address. I have questions. I'm not entirely sure I want them answered, though. But I am morbidly curious. Can you show me an example of when and why and where you're doing that? You can send it in the Discord as well, by the way, just so it's easier. If you actually do want to send an example. I'm terrified to actually take a look at that and see why. This is just the matrix for rasterizing. It's gonna be it's a matrix table I'm using to render images onto OpenGL. And I caved because originally I was trying to be cheeky about it and not do it this way and just have the index numbers. But all the documentation is this way, and it got really annoying because I don't have my little table memorized here. So I had to refer to it. I'm like, yeah, no, screw this. I'm not doing that. We're just going to change it over to what it should be, or to what it matches in the documents. Right, so regarding that float issue, as I mentioned earlier, so here's the table I was using earlier. You saw we have this thing called the GNU multiple precision arithmetic library, or right here. And for those of you who don't know what GNU is the great and recursive God. GNU stands for GNU, not Unix. Like I said, it's a great recursive GNU, or the great recursive God GNU, as I sometimes call it, because the G stands for GNU. But I just want to double check the license for this stuff. Yeah, it's a free library. Okay. Okay. So if we're doing it non-free, well, we can worry about that later. I have the document guide open already. I was reading it earlier because it's the floating points I care about. So we're going to test this library. And, you know, if it doesn't work, then okay. So let's go ahead and download it. Sorry, I need a folder open really quickly. Okay. All right, so let's pop it open, see what we have in here. Oh. Cool. It's not a library like I thought it was. Let's take a look at Mini. I think I actually have to build this library. It's not already... Is there already a pre-built one? No. I really don't want to build this. I don't trust myself when I'm building stuff that isn't mine. Right. Sorry, I probably should turn my camera back on. Elvin, not sure what you posted, but apparently the chat did not like that. Let me see what you did post. See if I can see it on my side. Sorry if you see random windows go by like that. It's gonna be a very important window to find later on. Yeah, it doesn't say. So I was looking at CSV Parser. I wrote some time back, then use a character. Oh, okay. That sounds terrifying. I mean, what I'm doing is a flattened array, as you saw with the matrix. So, yeah, I'm watching on stuff still. I had that happen a few days ago. It pissed me off. I let something render overnight and came back, my computer had restarted. I'm like, fuck. It didn't finish the render either. Right, so maybe I do need to make my own class. Because I trust myself more to do that than I would to compile somebody else's stuff. That said, chat, anybody here have ideas on how to, handle needing things to be... how to handle larger floating point values, like, because I don't get why this isn't acceptable. Like, I mean, even if I do this, I don't think it will work. Also, just to make my life easier, we're going to redo that in a second, but I don't want the extra stuff. So, yeah, I want to be able to go four floating point values out and have this work. I don't want to be limited to just 3 because, yeah. You know, and if I steal a bit that's in here, I'm just going to actually take this bit. And we're just going to go here. And we're going to switch that out for, what was it, test 3 and test 4. And do the same here. I mean, that should actually work for this, but I want to double check. So yeah, it is with the more precise version going, yeah, no, these don't match. These aren't the same number. The less precise version, it's working. Now, if I up this back to where I want it to be and do this, we get they're both true. The thing with this both being true, this one here, it's actually less true than it was before. So we have significant loss of precision there. So I'm just gonna make a note that 15002F works, and of course likewise works. So I just want that extra floating point. And even when we hover over this, it's giving us that information. 1068. 1984. Now, that should not be true here, because it's actually going to be checking that 9 versus that 0. But clearly that wasn't working. Now, when we reduce it, and it should work here, though, because we're only comparing up to, we're under that tolerance difference, and we're literally at the tolerance, as it is with this one. So I want to have that extra floating point. But without using that library, I really don't want to, to compile that library, honestly. If it was already pre-compiled, I would use it just because I know what they've done. I can look over their documentation, but when it's not, sorry, I'm trying to get the chat back up and I keep clicking the wrong one. When it's not, it just is, annoying, confusing, something, cactus-filled. Right, we're getting nearer to being able to render something. So we need to actually start getting set up with some stuff like creating our shaders. We need to Sorry, I was just looking at Discord to see if anyone had posted up what I was asking about. Because I asked about this on my Discord earlier, and I haven't gotten a clear answer from anybody. Alright, so we need to write a shader. We need to write a way for the shader to read in files. We need to write the renderer window more properly. What else do we need to do? Let me just get the OpenGL stuff back up. I closed it out on this one. Is it in the other one? Yeah, there we are. Okay. Useful. I have... Oh, that's the wrong one. So that's window... Table of contents. I had like 3 of those windows open. Glue, because I'm looking at the Wrangler thingamajigger to get all the stuff. My notes for what I need to do. So we need to have a... Oh yeah, so one of the other reasons why we need to make a decision about the container type is I need to write the math for unions, intersection, complement, and dot products. Now, vector, I think I already did the dot product in here. I think I called it dot. Yeah. We have Hamming distance. No, that's not Hamming distance. It's just distance. Probably should write a function for Hamming distance, though, to be fair. So yeah, that's the other reason why I need to make a decision on container types. Because, yeah, I need to write those functions at some point. Welcome back, Sam. Welcome back. I'm sorry, I'm trying to get this back open. I lost that window on my taskbar. Let me just get rid of this thing. So I was looking at how to get full screen by default and windowed full screen and all that stuff. Because I just use the default settings for the window I did create, which I have an editor. It's not editor. I don't know. It's the part of the renderer. Like, I don't know. Like, yeah, it's having special moments, I guess. We'll do DirectX 11 later. Way later, by the way. Wait, we do need to take care of the buffers as well. Do I have glue installed yet for the buffers? You know what we're gonna do? We're gonna install glue. I have that downloaded already. As you can see there, glue. So let's go ahead. Let's pop that open. And let's go to our dependencies. And in here, I don't know. I need to click this. I'm going to click, it's even on my window and I click the wrong thing. We're going to create a new folder called glue. All right. So, sorry, now I'm trying to get the chat back up. Hey, welcome in, Chica. How are you doing, man? So in glue, let's just pop this open. We need lib. And we're going to use the X24. We're going to use the static version of it. So let's just create a new folder called lib. Wait, is that static? Is that what the S stands for? Given the size of it, I'm going to assume this is the compiled static library. Okay, we're going to find out the fun way, I guess, right? Okay, so that's that. We need to have a include file. I'm annoyed that I can't find a way to get more precise vectors. And let's just go back to find their include. Okay. Does it have, does it have everything I need? I could just copy the glue. Yep. Okay, it has everything I need. So that's going to go in there for now. And now what we need to do is set up our dependencies. So, project. We're actually going to set this for all configurations. Okay, yeah, the output will be different, but yeah, it's fine. I'm in the wrong one. Linker. Okay, so we'll start in input. I don't know why it added all of these instead of the normal. Like, I have no idea what went wrong there, but yeah, that happened. Sorry, let me just find the include that we just did. Oh no, not the include, the lib. It is glue 32s.lib. I'm just gonna double check that. Glue 32s.lib is indeed correct. So I'm just gonna move this to the other window so I can have both of them open without them overlapping. Okay, we'll apply that. Let's go to our directories here, and we need another include. So that I believe is just literally the same thing, but glue. Yeah, it is. All right. So we're gonna copy that, create a new one, change that to glue. Okay. And then we need to add the library directory path. And sorry, I'm include.gl. Okay, so I'm just gonna copy this, and that becomes glue. And I believe this is just GL. I'm gonna double check that in a moment. Did I include the right thing? So we go to here. No, I did not. It's glue lib. Okay. Is that right? Yeah, glue lib. Okay, now because we're using a static library, I'm pretty sure there's a flag in here. Just really quickly. Oh, no, I want glue. Oh, I opened the wrong one. Yeah, but this is definitely a static library, I would say. I did not mean to open the compiled thing. I meant to open glue header. And okay, so glue static is what I need to include, and that is why am I blanking on where that actually goes? Like, I'm having just a moment here in my head of it's preprocessor. I'm actually going to actually very quickly put that back to this, and then we'll do the same for release in a moment. So it's glue static. In fact, I'm just a little bit paranoid, so I'm going to take this bit here and just go back into here and do that. Just because I am paranoid. Okay. And I'm just going to add it to the release version as well. Cancel. Apply. And to the release version as well. Okay. Now, let's just build, make sure we don't get any errors. I mean, I have the warning still. Okay, I don't know what library that is. Let's find out together. And that is error 4098. No, I want link. Because I think it's L-I-N-K. Now I'm doubting myself. Oh, it is L-I-N-K. Okay. All right. All right, so I just conflicting with a library, and let me just go to just having glue, see what we get with this. Okay. That just seems to be something that you can take care of later. That's fine. That's fine, fine, fine. I'm assuming, Chica, you're being sarcastic, by the way. So let's take care of our buffers. I think we're going to do our buffers at least. Okay. So yeah, we're gonna leave this in editor for now. I'm not sure where I want to put the buffer, to be fair. So we need a, we're gonna need, I'm gonna put it in renderer for now, but we're gonna need, we're going to create just a regular buffer class. And we're going to do that here. So add, new, and just for ease. Cool. It's a header file. It'll be buffer. All right. Cool. Grab that. And we need to include GL. Okay, why do I have two GLs, by the way? What's going on there? Is that part of that issue that I saw earlier? No, okay, it's the same thing. Interesting. All right, so, and we're gonna do namespace, and I'm just gonna copy. Don't know why I started putting semicolons there. Okay. Also, let's keep to my convention for that, shall we? Okay, so for our buffer, what do we need? Hang on. Oh, that is literally... Sorry, it was one of the other windows I had open from glfw and glue, and not this one that I moved here. Give me a second to search through my history to find the one that I'm looking for. GLU, I think. I think it's GLU for the glue stuff, if I remember correctly. I wrote a note for this elsewhere. Yeah, it's GLU. Okay, so now I know what to search. So it's GLU buffer. Okay. Sorry, let me just bring over the Wikipedia from the people who wrote glue that I'm reading. Sorry, just also let me get the chat back up in case somebody has comments on how to do buffers. I want to bind bind buffer. Kind of what I was actually looking for. Okay. because we have to bind it. I heard the Peltram's. Wow. I'm just not gonna comment on that one. You should be sorry for that. You should be very sorry for that. Okay, so we're gonna have to do this first. So let's pop that open. Okay, so all right, I'm just gonna move that to the side because that gives me a rough idea of what I need to do here. Well, first let's just name our class, and I'm just gonna call it buffer for now. Also, I just moved the GL glue stuff directly over, so this is gonna be class has 2 S's in it. Sorry, I'm just resizing this so I can read the chat still and have that on screen in a reasonable way for both. So, I don't know what we need to pass into this yet. Oh, sorry, that's the class declaration. Oh, I was doing constructors. Okay. Speaking of which. Let's just grab all of this and I'll change things out as needed. Yes, I know window doesn't exist here. Get over it. All right, so this is buffer. And this will be buffer. Okay. So we need to do that on the gen. So the way I'm going to do this, just to make my life easier, because I don't know quite how to do this, and I'm just looking over this documentation, is I'm going to create, because we need to first have the GL gen buffers done, right? That's what that earlier document had said. So we're going to go here. No, I don't know why. I mean, I do know why, but I don't know quite how this works. I haven't actually looked at what it's doing. We're going to create our buffer class, and we're going to actually first include our keyword here of include, and we need to go back 1 folder. Sorry, I like having Linux style. Okay. All right, and so we have buffer. Oh, sorry, hang on. Using namespace, and it is Neuron Engine graphics. Cool. All right, so we have buffer, currently with no return, and we have buffer destructor. Okay. Right. So we need to do, does this, it's void, it returns nothing. But it needs the GL unsigned integers. Okay. So let's first call this up as, oh, hang on. Have I included the, yeah, I did. Okay. So GL, lowercase GL, yeah, GL gen buffers. Cool. And it needs an N, and we don't have an N defined. So, we'll take care of that in a moment. And it needs a reference to an ID. And it needs a reference to the buffer ID. So specifies an array of buffers. Okay, so this is with the, so this is where the data is going to be stored. So that's going to be a member variable, or member attribute. So just give me 1 second. I'm gonna just bring this back over here, and I just want to take a look at what, if it really is what I think it is. Okay, yeah, so it is just a unsigned integer, isn't it? Yep. Cool, that's what I thought. So okay, so it's just an ID. Okay, so we're gonna call that buffer address, and we're actually gonna make that a member. So it'll be buffer. Actually, buffer name. Yeah, we'll go with buffer name. Okay, so let's define buffer name in our header here. Just let me steal our attributes, and this will be private. Okay. Right, so we'll do here then is G, what was it? Sorry, let me scroll back up. GL, capital GL, unsigned integer, and I can't remember what I just named them. Buffer name. Cool. I don't know if I need to default this out to something. Sorry, I'm just looking at the documentation. It doesn't. APIs such as pixel transfer, vertex format APIs take enums, especially one of these types. Okay, so it's actually an enum. Cool. Right. So wait, is it actually enum? Did I misread that? OpenGL has a number of predefined types that should be available across various bindings. These are useful in ensuring cross-platform portability, so since all platforms will use well-defined sizes of parameters. The table shows the C names for the type as well as their bit depth. OpenGL requires that these have the same exact bit depth below. This describes them and provides an enum for some of them. Many APIs, such as pixel transfer, vertex formal definition APIs, take enums that specify one of the types. Okay. Huh. That would be an interesting thing to have used elsewhere. Sorry, I'm just looking at some of the variable types. Also, as I sit here, I stuck my hand in my pocket, and I just realized that I'm missing a headset. Because there was a headset in my pocket, but not the second one. And I don't know where it's at. Alright, I will take care of that later. Right. So do I need to give it a value? Can I just leave it on whatever? Undefined. Yes. Well, no, because we're going to define it on construct, but I'd still rather have something here. Just makes me, yeah, and things aren't here. Okay, so N. All right. What is this N going to be? I'm just going to Google that really quickly. See, there's an example bit of code out there. Literally what I just read a second ago. Cool. Useful. Tomato. Literally. All right. Oh, hey, here's an example. Y1. Okay. I've actually read something by this person because they're the one who I pulled some of the... I want to see something in there, this person's work. This is definitely the person who I had used earlier, who's one, like, if you saw when I had S as one of the notes for the different perspectives, it was this person. I recognize the name or the URL. Oh God. Oh, that I don't know why that hurts my soul, but it does. Way back in the day. Back when Lucasfilm owned Star Wars properly. Before the House of Mouse came about. I was subscribed, because I was a big Star Wars nerd, to the Star Wars magazine. Back when magazines were a thing. Yes, I am that old. And in this magazine, like, this was before the prequel trilogy. I remember the magazines leading up to the prequel trilogy and after the prequel trilogy too. But in this magazine is either the inside cover or the back cover. Always advertised what I thought was a video game, honestly, and I was like, oh, this game is never going to come out. It wasn't a video game, and it was already out. Called Cybertown. Now, cyber in this case means digital, not the adult activity that some people enjoy doing online. The reason I raised that, I never told people about it who on other chats, like, oh, I don't do that. Hey, there's my headset. I don't do that. That's inappropriate. It's like, it's not that. It's like a role-playing site. This role-playing site called Cybertown, which I don't think exists. Okay, hang on. We're Googling this. Does Cybertown still exist? Okay, it's not that. Yeah, Colony City. That's it. This is the thing. Okay, so oh my God, does it still actually exist? The atrium. I remember. Oh God, I forgot how ugly the chat was. Oh, there are people online. So yeah, the ad would be like the picture of the atrium, this area. You can tell how old the site is, like, just by looking at it. Like, ooh, hang on. Okay, I'm doing this in a different window. Just, I want to see if that actually still exists. Oh, no, you can't log in anymore. Of course, it's a way back when machine. Clearly you can't. Oh, that is sad. Okay. So, this thing was advertised in the front and the back of or front or back, one of the two, I can't remember which, of the magazines. And it was a markup language called VRML, Virtual Reality Markup Language. It's how they made their 3D worlds, actually. Let's see if we can get Cybertown back up and see if we can get some pictures from here. My chat was not... I don't remember my chat being green. But yeah, a 2D version and a 3D version. This is a 3D version. It's always fun to see who like, yeah, there was a bit of elitism. I don't remember any room. Ooh, that's YouTube. We're not gonna do that. Bad. But yeah, no, that this is what it would look like. God, my memory of this place makes it look so much nicer. Not it. That's from the video game. That's from it. That's the jail. When you got certain bands, you get put into jail. You can still chat to people, but they can only do it in the jail. Yeah. Oh, the map of the thing. Yeah. Yep. Sorry. Anyway, all the I ended up learning VRML to do it. Now you either needed 3D Max at the time because 3D Max was the go-to thing. Blender didn't exist yet, or at least wasn't talked about if it did exist. I mean, Toy Story had just come out like around the same time as I joined this thing. And all like if you did VRML outside of an editor like 3D Max. This is actually the first time I ever installed Notepad++, by the way. You had to do it by hand. And what you were doing was literally this stuff. You were saying where the vertices were, what the colors were. Except for they weren't done in integers. They were floating point numbers. Every single one of these is a floating point number. Okay, so I remember messing with one of them and getting an effect I had never seen before. I was like, ooh, I like that. Yeah, so that's why I said, oh, this hurts me, because yeah, it reminded me of stuff from back in the day. I'm pretty sure I did not want to close that actually. All right, so that's a macro we're gonna have to do for the bind. So I already knew it was I already knew what the order of these were, or not the order. I already knew it was this, then that. I didn't know the gen buffers. I learned that by reading that. But what's this subdata? Let's go back here. Oh no, hang on. Let's go back to this one. We're gonna open up the bind really quickly. Okay, hang on. Gen buffers, bind buffers, buffer data. Okay, so we're going to have two constructors, I think. I think we're going to have a constructor where we don't have anything bound. We'll have a bind method. And one where we will have something we're passing in that's bound. So we're going to do the non-bound one first. So yeah, what I was reading from them when we say that was this bit. But I still want to work out what the heck... Oh, I can click this. Fuck. That would have been useful. Okay. Hang on one second. I just want to see something now. I don't know why this one just seems easier to read for me. Right. I know I'm going to need the array buffer. Do I need a... I don't know if I need that. Okay, so I think they're just clearing out the sub buffer. I think that's what they're doing here based on what I'm reading. I could be like way off on this. I'm gonna skip this one because I didn't read anything about this. I read about these bits. Wait, hang on. I think what I said earlier about the bind thing was wrong. Okay, that's stuff I need to worry about down the road. Okay. Wait. Okay, no, I get it. This has to be one. Okay, I see what's happening here. So, this thing, this GL array buffer here. We need to bind that particular one to the first index. So we're going to go one there, I think. I really have no idea if I'm reading this right. Yeah. I fudge if I know. But hey, to be fair, there's a one there. So I'm going to assume that I am not going crazy, right? All right. So we have that bit. And after that is the GL bind. Oh, hang on. It'd be helpful if I did that, I guess. GL bind buffer. Is that bind buffer? Yeah. And then, again, I'm just reading. I'm going to post in the chat, by the way, the document I'm reading from, just so you all have it. And that way you can correct me if I'm misreading this stuff. But there you go. That's the document I just had on screen that I'm reading from. At least I think I just pasted the right document in. Yep. That is. Okay. This is the older version of GTL, that document. Oh, God. I'm in 4.5. So, I've just reloaded it. There you go. Whose GitHub do I have open? I don't see it. Okay, whatever. All right, so we need to pass in. Really want this and the chat to be on the screen at the same time. GL buffer. So GL array buffer, sorry, array buffer. And then the second argument is the ID. So that would be our buffer name because they are using vertex buffer. So buffer name. And then we need to do the buffer data. Sorry, I'm just gonna bring this back over now. Buffer data. Okay. Just want to see what they're doing here. Buffer draw. Okay. What is draw? Just want to double check. The data stored contains are modified by the application and the use of the source for GL drawing image. Okay, so we need to work out. I'm assuming we're going to be doing drawing. Just following that logic. Okay. Right. So our target, I believe, is this enum, this buffer. Our size. I went too far. In bytes the buffer, then okay, so we need something for that, where you're going to need size to come through. Now, what do they want for size? That is, okay, that is that pointer type there. I'm assuming GL size I pointer. I'm not sure what the I stands. Image pointer? Sorry, I'm trying to find the, I'm not sure what the I in that stands for. It doesn't really matter. It's what they've named it. Okay. So we need something for that. We're going to call it size. Like that. I'm going to call it object size. I'm also not going to do anything with it beyond that because you know what? Hang on. That is not what I meant to do. That's actually what I meant to do on this one. Okay. Can we head over there, please? Thank you. Okay, no idea. No idea what it is. I'm not gonna initialize it to anything because. All right, let me get the documentation back up. Okay. So yeah, we were just gonna call that object size. What did he call it in this, or she, or whoever wrote this? Data size in bytes. Cool. Our third argument is our data. Okay. So in this case, because we're not copying data, we're setting up the buffer. We don't need anything for that. So we're going to do null or 0, I think. No, that's only... Okay, so this is the part I was talking about earlier where I said, oh, we have one where we pass something in, one where we don't. This is the bit I meant that for. I knew that I was going to do that somewhere. Right, so its type is what again? Oh, it's GL void. Okay, so I see. Okay. Okay, that's wrong. That's not what we're gonna do here either. Right. first, let's get object size over into here. Oh, hang on, wait. Let's first then actually do the next bit and actually start doing our GL buffer data. And again, we're gonna pass in our buffer, and then we named it object size. Okay. Now, no idea, and I think GL static draw, based on what I was reading on that document, is accurate. Okay, so I really don't understand what this little bit here is. All right, so we don't know where we're passing in, right? And it's already defaulted out to null, but we don't want it to be null because we want to pass something in. Oh, hey, that's what I was looking for earlier. I is non-negative integers. Okay, let me just go back here then. I've definitely misunderstood something. Not what I want. This is the bit I want. Yeah. Const GL void data. Data specifies a pointer to the data that will be copied in. Specifies a pointer to the data that will be copied in. Okay, so we have target, we have size. So that's the size in bytes, which is why we used the that thing. So target, size in bytes, data. Okay. So I didn't misunderstand that. I just got myself turned around. Cool. Specifies a pointer to the data that will be copied in from the data stored for initialization, or null if no data is copied. All right, so you're passing a 0 down here. Cool. Just make sure I got that right. Size and bytes, yeah. Okay. Hang on. Oh, God. Bloody. Okay. Okay. Sorry, I knew there was going to be 2 types of buffers. I just thought it was buffer, and I didn't think of the other type. We're just going to rename our class here. Give me a second. This is our vertex buffer. Okay. And we're going to do one more change here. And I don't think I've built since doing this. So hopefully I can pull this little awful stunt off. Never do what I'm about to do. Oh my god, never do what I'm about to do. Okay. Oh, yoink, yoink, yoink. Okay. Still expect you to fail, because that line's not done. Okay, there we go. Huh, now I have 2 libraries that are... Okay. Alright, yeah, we'll come back to that later. Okay. Gave myself a bit of a heart attack doing that horrible thing I just did to my code. Don't ever do what I just did. Ever. I wonder if it's this. That's not what I wanted. I just want to go back here for a second and go back to Google. This is literally the same thing I just read. Just different formatting. Okay, even though I don't understand what's going on, I have the weirdest feeling that that doesn't work for some reason, but that's not what I'm looking for anyway. What I'm looking for is bind. Oh, yeah, bind. I'm looking for buffer data. Not subdata, buffer data. It would be lovely to have seen how you define that. Okay, so that's the second person to do that. It wasn't you, it was the person who was on the other page. Okay. Well, we ended up doing me following tutorials and reading stuff day anyway. Okay, we're just gonna go for examples now. Okay. Also, what the heck? Oh, I put the word vertex buffer randomly there. Cool. Don't know what I was smoking while doing that. Okay, so maybe that's wrong. Maybe it shouldn't be that way. Oh, hey, I read this the other day. That's pretty creepy at high square. And that teapot. I'm not sure I showed you guys a teapot. Not my teapot, to be clear. I just saw somebody had rendered a teapot using as an example for the perspective view stuff. I mentioned it earlier as well, but I'm not sure if I ever showed it to you. Sorry, I thought I just unpinned something. Okay, so this is actually wrong. We're going to just do this with question marks for a second here. All right, so it seems like everyone that we're reading is using either size of, and then whatever's over here, or they're doing something else times size of whatever is over here. Okay. At least that's, let me just double check that is correct, because I've gotten this back, just open Netflix, gotten this backwards a couple of times now already. So, of the vertex, yeah, that's what they're doing there. Oh, no. Okay, that's not what he's doing here. Okay. Hang on. Was that the multiply one, or was that just the non-multiply one? Before I make a note on that one. That was multiply. Okay. So, that was type in this person's. So, it's the type of whatever this is. So, it's not the size of the integer. That second one, for example, or uint. Sorry, it's not the size of the U short in that one. It's not the size of appendices. It's the size of what is the type of appendices. So U short. It's not p vertex. It is what p vertex is, which is a transform. Or no, it's not transform. It's a shader. Vertex, no, it's not a shader. It's, I can't think of the word for what it is. The thing on the screen. Like, I'm blanking on the wording. I'm just, yeah. Okay. So that's how this person was doing it. How were you doing it again? You just had the straight up whatever it is. Cool. Straight up whatever it is. Cool. Swear I saw another one while we were doing the Googling. The Googling. Google, you must. Okay, wasn't that. Wasn't that. We're just going to revisit the articles we were looking at earlier. I think it was in here we saw one of those types. Buffer data. Copy buffer data. What? Okay, you're like passing nothing in, so it wasn't you. You were the one that just confused the crap out of me. Okay, maybe it was just those two types I saw. Right. Do we use auto? That seems like it's going to be a nightmare to use auto. Like, auto, whatever. No, that would actually not work. Okay. So. I can do a drunk Yoda impression later if you ask nicely. Just not on live stream, because, oh my god, I don't want to be demonetized. And yes, I am mouthing an actual skit around that. Okay. And hopefully the smack at the end, hint, hint, gives you an idea of what the particular bit I was doing was, but yeah, we'll talk about that later. Okay, hang on, just screw this. We're not going to search for GL. Okay. So, not multiplied. Size of whatever you're passing into there. Okay. Plane particles. Let's take a look at plane particles really quickly. See if we can find that in here. Give me one moment. Sorry, if you can see the light bulb starting to like bloom in my head there. Okay, so it's gonna be float, integer, or one of the variants over here. That I know. Okay, so remember how I talked about the VRML stuff and how it was done, and looking at that and talking about how it reminded me of it. Literally, that's what everything we've looked at is. There just one person did it in float, one person did it in, what did this person do it in? GL float. Okay, so it's gonna be float or GL float. Okay, so we're literally just passing that data along. So, hang on. I feel like this would only render like a single object. Something about that feels wrong to me, like the non-multiple approach. Okay, so we don't know how many things were rendered. Okay, so cool. That 3 that person had up there on that comment I just made. That okay, so hang on. Can it be an integer? If it can, I'm just gonna use a uint. Okay. Did you do multiply in yours? No, you didn't. You just need the data size of bytes. Okay. Okay. So... I mean, this is really, like, useful. I don't know why that one made sense to me. Okay, not useful. Not useful. I would like to see them without null pointers, please. Thank you. Okay. Yeah, I get it. Okay. I don't get how to do, like, I don't get what I'm, like, okay, I get what it's doing. I don't get how to explain it. Okay, so I want to find something called the vertex in here really quickly, I think. Useful. Okay. Let's go on to the next example. Okay, I get it now. Okay. Int 64t, not unit, int 64t. Count. Now that's make me think of vertices. N. That make me think of capital N. But that's going to confuse me if I have to use lowercase n. It's going to drive me up the wall. What was the first one I said? Number? Or something like that? No, because a lot of people use number of vertices. Kinky. Fair enough. Amount. Really? Okay, include SV int. Thank you. Okay. Because this is, like I said, we don't know what we're passing in. This is, I knew there was something about that from my reading the other night. From last night. So, how do we get this type? That's the part that I can't remember ever seeing it. Okay, I didn't even think about that part last night. Okay, so indices is what you named yours. What is indices in yours? Just so I have another idea. Hang on one second. Okay, we're not using uint. And I have a couple of reasons for that, but I don't know what we're going to use instead. So I picked uint 64. Okay. That's because I just wanted something that was unsigned, right? I really don't need that size. right, so we can use GL size I. Wait, hang on. Sorry, I thought I had used. I just had a moment where I forgot what I had used. Okay, so GL60. We could use a GLU int 64. Can't use GL short or GLU short. All right. All right. We did 64 here. We'll do 64 here. Sorry, the reason why we can't do that, well, I mean, we could. But if you remember earlier when I was reading through this and there was that comment about system being system agnostic, and that's why they were using it, and I just had the issue where, hey, I couldn't get that unless I included the header, which is interesting that I don't need the header for it in other places and have zero issue calling it up. But here, yeah, I'm getting that issues. Farmesh should have Farmesh. Please, Pascal case buddy, should have far dense patch table for dense mesh indices. Just want to see what the thing that you call indices is. Vector of integers. Okay, so still on numbers. This is going to be a number. Why are you passing? Oh, okay. Okay. Yeah, no. Okay, let's go on to the next example. I just want to go into the next person's example. I've already done that. I've done some of these. Okay. I'm just saying where. Okay. Numbers. We're gonna go with floats because it's making me like everything I'm seeing. Like when I look at this bit, like the second I got to there, my eyes instantly dropped down to the highlighted line, saw that it was vertices, went numbers. Like that's why I just said numbers. And it's just making me think of all the crap from back in the VRML days, oddly enough. And as a result of that, I just have the weirdest feeling that we need to use a float. And so I'm going to use a GL float. Anything in the buffer, if you see me start typing in a standard sort of number, be it float, double, integer, what have you, call me out. I want to use the GL stuff because that cross-platform comment made me kind of go, well, technically a Mac is cross-platform for me. But I'm also thinking about like, Xbox and things like that. And one of the things I was looking at when I was looking at different choices for renderers, be it OpenGL, be it DirectX, be it that explains some of my confusion about something. Be it DirectX, be it something else, was that technically any of this should work on an Xbox from doing this from a PC. So kind of want to use that as a test point. Really don't know I ever will, but hey, I can have pipe dreams, okay? So what I need to see here is this is a pointer, so you want a pointer. Since we're passing this in, we're probably not going to be passing in a reference. So GL float, yep. And what are you called in here? Data. So we're going to call you data as well. Paste that in. And data. Okay. Let's just grab this GL float thing. Paste that into there. That's going to drive me up the wall, that extra space. And so we will do data. Oh, type data. Okay, and data there. Okay. Right. I completely misunderstood what that was for, so we're not going to use that at all. Trying to get the documentation back on screen. Okay. So we have that at least. We have that. We have that. Sorry, I just need these open side by side now. Size is the third one. Size is the third one. Okay. So what we're going to do next then is GL buffer sub data. And then we're going to use the GL array buffer again. Okay, so again, it's amount times size of data. Okay. Then it is of type data. And that's 0 in yours. Offset. We don't want the offset. Okay, that's where we're... Okay, there we go. So we don't want any offset. Okay. Right, I can close that window, and I can go back to the one I was using earlier. Hit forward. All right. Now I want to put a semicolon there. Okay, should not be giving me an error anymore. I think that's what I want to do. If fail bind index 0 instead. Think that's bind buffer again, I think. Not entirely sure on that one. Okay, so that's the constructor for the vertex buffer done. Sorry about that. Watching me learn this crap. Okay, so cool. Yeah, but where did that page go? Okay. All right, so we're going to want to be able to bind something to this buffer, and hang on, I'm trying to find the wording. Oh, I know I saw it, because it's one of the things that helped me work out what delete buffers. Okay, hang on, just give me another second. I just want to take a look at bind again. All right, I'm not sure if the unbinding is bind it to something else, like you clear out when you do reference in Unreal, or if it's a delete buffer. So we're not going to do that one. We will create the method at least, though. So we're going to need to be able to call this up from other classes. So this is going to be protected, private, public. Also, we're not in attributes anymore. We're in methods. Okay, so for this method, we're gonna have, do we have a return on this? No, we don't. Oh, that's delete buffers. Bind buffers doesn't have a return either. So it's gonna be void bind buffer. Okay, void unbind buffer. And no idea what to do here. Okay, let's just take both of these, go in here, and define them. Wow, I put a semicolon there. All right, so binding should be pretty simple. We're just going to call up the glf bind buffer here. And keep the array. Sorry, I'm trying to find that again. So it's the particular buffer ID. Yeah, it's a buffer name. Buffer, yeah. Oh, okay. Ta-da! Sorry, if everyone doesn't get what just happened there and why I did that. I thought I was looking for something else, and I've already done it. So I was just confused. Okay. All right, so yeah, that's one buffer done. Now we need to do our index buffer. And I also need to take a bite of something because I'm going loopy working this out. Hey, welcome in, Aspect. I'm still here. I'm just eating something really quickly because I haven't had lunch and had a late start due to issues. How are you doing today, man? Hopefully everything is going swimmingly. Better than me trying to understand how binding buffers works in code. Like, conceptually, I very much understand this. Like, I get at a very high level. Implementing it? So someone yesterday came into the chat. Nice person. He's on the server. Lovely, lovely bloke. And he said, oh, I really hate how fast you can do this. This was Unreal programming stuff in Blueprint. So really, really simple, straightforward to me kind of stuff. And it's all about breaking it down to the smallest problem. Here, like, I got to the smallest problem I can think of. I know I need this sort of thing, but what is this thing? That's what we spent like the last, like, what, 30 minutes of me working out. This is probably going to be a float. Or an array of floats or something like that. So, hey, pointer. We can put arrays in at least. But I'm just sitting here like going, this is like how the person felt yesterday watching me is probably how I feel reading some of these tutorials. Probably is similar to how I feel reading these tutorials that I've had up on screen. So like, you know, as you saw me, I mean, I know this is the actual documentation, but you saw me have examples up from other people. Like, this stuff is an area I've not actually done before, and well, I conceptually get it. And I get a lot of the math underpinning it because it's similar math to other things I do. But its application is completely different. I don't get the application of the math. I get the concepts of the math, and how it works, don't get the application, because, yeah. Yeah, but this stuff is, like, again, I get the high-level stuff. It's just, hello, how, I don't know my ass from my elbow in this case, it seems. I think I have done this right. I mean, for all I know, this gen buffers should actually be 0. For anyone who doesn't know why I picked 1, it was because it was what they did. Okay, and almost every other example we looked at had the 1 there as well. Like, I was quietly looking at that as I was going through, going, please, everyone be using a 1. I think only one person didn't, and I don't remember that. I had a variable there, and I didn't look up the variable. Like, I don't think it was like the last one I looked at too. So I'm like, if you're not using the variable, or if you're not using 1, you're using a variable, probably it's going to be 1. I'm not going to waste the time. But I have no idea if half of this is going to work. I also have no idea if I should really be putting this in renderers, creating a memories folder for this. Like, one of the biggest things about this is it's been a nightmare for me. Is, while I've worked on big projects before, this is probably, to be fair, the largest thing I have individually undertaken in terms of code. Well, okay, no, that's actually true. This is the largest individual coding project I have taken on board. I have had coding projects within larger non-coding research projects. But again, that was all really simple. This, to me, trust me, like, research programming is a joke at the end of the day for me nowadays. This stuff is legitimately well beyond me in terms of I can break it down to the smallest part. Which is where I wanted the guy yesterday to get. Like, I wanted him to realize that you have to figure out how the mouse has to register that you click the object, because he's working on spinning objects when you click on it. Okay, well, one, the mouse has to be able to see it. Can the mouse click that far onto the screen? Which is just changing a floating value if you need to, but whatever. Like, if we got to that stage, like, okay, I get this. That's the stage I'm at. I get what I need to do and what it's doing. I just don't know how to actually do it now, which is a weird spot to be in. And I don't know how to search for some of these things, so that's something I've noticed, by the way. The more I do this, this being any particular sub-subject within the field of programming, the easier it is for me to find data on what I'm looking for. Unless I'm looking for something really, really uber specific. That was a comment somebody made about something that's insightful. For that, I have, friends who help me find that crap. But as I get more comfortable with stuff, it's become so much easier to Google because I know the terms, I know how people are using it. With this, I'm really just tempted to type into Google, how make buffer GL glue, and pray that I get a result that works. Now, my example search did turn up a page I like using whenever I don't know how to actually implement some code. Usually, again, I only use that for when I don't know how to implement code, but I know what the code I need is. In this case, it was useful in seeing, okay, what are people passing in? That's how we worked out that they were passing in some form of an integer, be it a float, be it a GL float, be it an integer in some cases, a couple of cases, but it was a number. From there, we worked out that, okay, well, if it's a number and we were thinking about cross-system, we should be using the GL numbers, which is why we have GL unsigned integer 64-bit for amount and GL float for data. And I picked float not because more people use float. Actually, I think based on what we were looking through, about half the people use float, half use integer, with one person using a set of vertexes. An array that was a set of floats. So I tried to go with float. Just because, well, one, while half people were doing it and an array person was doing it. Two, because, the VRML stuff I mentioned, I'm really glad I remembered that stuff while I was doing this, was all floating point numbers. I even made a comment when we were looking at the integer one. Oh yeah, these were all floating points in my thing. So we picked float, and because we're using a float, and again, that cross-system stuff, we're using the GL version of it. I am really curious to see how they defined their Wait, hang on. They didn't. Never mind. I thought they had a different float. I thought they had a longer float for a second. It was the integers they had, like normal C integers. Oh, I'm ages away from grokking it. I'm closer to understanding than to grokking. But when I have my camera on, you could see that light bulb moment. Like I was looking over at my face because my face is right next to the chat on my screen, and I was like, oh, I could see as I was reading and checking the chat and seeing my face, like my eyes getting wider with understanding. Like as a light bulb just clicked on. I will say, interfaces are the one thing, or one of two things, I definitely prefer doing in Blueprint than in C++. At least Unreal interfaces. A regular interface, yeah, okay, that's fairly easy. Virtual, whatever it is, its signature 0 or equals 0, and then you implement it wherever class you're overriding it in. The Unreal ones are actually really, really smart in what they do. Like they're idiot-proof things. When I say idiot-proof, it means like you can't accidentally call up an interface for something that doesn't exist yet. Where you could, in theory, if you didn't do your checks correctly, in regular C++. You can build the checks in, don't get me wrong. Like it stuff's there for that, right? But it's already pre-built into the interface for Unreal. So it's already kind of going, yeah, no, I'm not doing this. That doesn't exist. Bye. There's some other things they have in there for replication stuff that I haven't taken a full look at. I need to because I use a lot of interfaces when I do replication because it makes life easier. Also makes the data more secure and encapsulated, of course, just like why you would use an interface to begin with. Though, Ben from Game Dev TV, I think it's Ben at least from Game Dev TV, he has a project up on GitHub that is replication with the regular C++ interface instead of the UE4 interface. Now that said, UE4 does have a method member method inside of its interface class that allows for you to actually do a check before you even do the interface call to go, okay, so I know it's going to be this thing. I know this thing exists. So instead of having an error on you actually not finding the implementation of this, check, does this particular class actually implement this interface? If so, then yeah, please do the thing. Do the thing. That part I really like, but coding that all in Unreal is like an extra line and a half, which I realize isn't that much, but it's their particular API syntax, so it's not exactly the easiest syntax to work with, I find, which is why I definitely prefer it in Blueprint. That and how you have to add it in, all the, like, yeah. There's some weirdness to it that just I don't like in C++. It's one of the few things I prefer doing in Blueprint. Other things, like, I definitely prefer in C++ for Unreal. Right. So, because I only planned 4 hours today because I'm still not feeling 100%, what we're going to do is we're going to be really cheeky and do our index buffer. But we're going to do this in a very funny way. I'm just going to copy this because it's literally the same thing with some minor differences. If you don't know where I'm pulling that from, when I was reading the document I posted up earlier, this stuff, that's what they've done. So we're just going to follow that particular approach, and yeah. Really? Fine. Put it in renderer for a second. And we're going to name this index buffer. And we're going to do the same for that. and I'll put it in the correct folder in a second. And that's going to be index buffer class file. All right, let's just change that from vertex buffer to index buffer. Actually, you know what? Let's do this properly. So vertex buffer. Why does it have oh, because the RTS stuff. I don't know why that's still in there though. That's like from months ago. Index buffer. Okay. And just gonna make sure I don't do anything weird in there and save that really quickly. And we're gonna do the same thing here. And there we go. Okay. So I'm just gonna build real quick to make sure that we have no errors. Oh, okay. Oh, I guess I copied that file before I saved this bit. Okay. So let's just go down here. Right. And now I'm going to pop over to that documentation I had up on screen a moment ago, and I'm just going to double check what differences there are between the two. Okay. There doesn't appear to be any. Okay. So go to Google. We're going to do index versus vertex buffer, open GL. Oh, okay. So according to the documentation, by the way, we're going to rename this to count because that's what they're saying it is. It's the count of the number of things. So just to keep in line with their documentation, we will just do that. And yes, I know I could have used the rename feature, but for those of you who weren't here a few weeks ago when I had an issue where it renamed the wrong stuff, I'm still like paranoid after that experience. And am too afraid to actually touch it. Okay, so yeah, this is okay. Okay, so just I took a quick scan through this, and I can see why some people are using int and why some people are using float, to be fair. For the that'll be useful to deal with later on, because of, you know, how things are being put in, right? Hey, look. Sorry, I was just reading something on this and I just got distracted by something else I was thinking about with it. You know, I want to change one other thing we've done. We're going to do that, and we're going to do the same in here as well. And then what I want to do in this class file, because I haven't implemented any of the API stuff, so I'm just going to do it up here really quickly, is do count. Nope. Count is equal to count, right? Cool. And I want to swap those out. I'm going to do the same in here, is equal to count. And we're gonna do that instead. Okay. Just again build to make sure there are no errors. Cool. I know the linker thing is going on. I know I have warnings about things in the math library that I need to take care of. Okay. So, sorry, I'm trying to find the documentation again. Okay. Let me just get back over there. All right, so the indices for the indexed version in this are integers. Okay, so we're gonna use integers instead of floats. So let's go back here, and now they're gonna be unsigned, I'm pretty sure. Yeah, it's gonna be unsigned. We don't need a long version. I don't know why I would even do a long version for that. So we're gonna use this one. And we're gonna change out our data type, because now we're not looking at the particular things, but the number of whatever they are within that, because we're indexing it. Sorry, I didn't not need to open that up. Oh, I could just use float. It just is a type def. I'm sure there's more to it than that, but whatever. Oh, we'll change that to, that as well. Okay. And I mean, we could wait. No, this is wrong. No, okay, that's wrong. That's what I meant to say. Which also means that we fouled this bit up as well. And this should be GL float down here. Crap, hang on. Undo what we did here. This is what I meant to put it in. Cool, let me get the documentation back up to double check that other line. So it was this bit, and useful. Let's find the example page we were looking at earlier, which useful. So I'm going to assume that it's also that for now, until we get to the next step and I can actually test it, which also means this should be GL float. Yeah. Okay. Right. Now to get that document back up that I didn't mean to close. Yeah, unsigned and yep, okay. Oh, hang on, I want to be in that page. Cool. Okay, yeah, no, that's right now. That okay. I'm feeling much more confident with that being somewhat right. All right, so buffer, yeah. Sorry, let me just go back to this version of it. No, yeah, this version. Okay, that stays the same. That stays. We could rename it index buffer, I guess, but I'm just gonna leave it as data for now, because it's the type that it is. Sorry, I'm just pointed to the wrong thing. This is the delete buffers. So if we go back to bind buffer. No, we want to go to bind buffer data. So yeah, if we go to this one, it's data. So we're just going to leave it as data. We're not going to refer to it as indices. Just otherwise, I'm going to, at this rate, lose track of what these things are. Okay, so that's one thing that's different, by the way, that I got wrong. It is a GL element array buffer now. Okay, so this should now become element array buffer, and so should those. Okay. And did I ever implement this thing? Yeah, so we're gonna take this bit now, and we're gonna change out that segment there to that. Okay. I need to do more research on buffers. So let's just build this. Make sure that it builds correctly. And we have built correctly. Yay. Let's close our external dependencies. Yeah, and this really isn't editor. It's part of the renderer. But we're going to use it elsewhere. I'm not sure I'm going to have that. All right, so we're past the 4-hour mark. And I said I was only going to do 4 hours today. So unfortunately, that means that, hey, we've reached the end of today's stream. Sorry, we only did one of the game engines. But hey, because we're completely doing something just random, have fun looking at... Oh, by the way, I'm looking for breath sounds. That's the search. This thing from Unreal that I'm working on. Also, let me get full screen because the UMG widget is not properly set up yet. So things are slightly off. Yeah. Yeah, I know I'm losing frames, but that's just because... Yeah. And boom. Boom. Notice it changes the oxygen rate. And did I ever get the flashlight to... Oh no, I forgot to put the flashlight text up. So yeah, when we turn the flashlight on, it should say flashlight active. It'll give you battery warnings. Despite me quickly draining my battery to the side there, as you can see. But yeah, that's other things we're working on. We'll continue doing this on Fridays probably for a bit. I have animation stuff to do as well. But yeah, I thought I'd show that off just, you know, for the lulz of it all. Alrighty. So that takes me through what I want to cover with you guys. If you've not already, make sure to hit the like button down below. It really does help the channel out. And make sure to hit the subscribe and notify bell so you know when the next tutorial is out. As always, this video and my tutorial series are brought to you by Patreon sponsors. And you can help the channel, as I said, by just hitting the like button. All right, I will see you on Monday for the next tutorial, or next Friday for the community live stream at 5:30 British Summer Time. Man, I love seeing that project. Reminds me of the Moonbase Alpha, just more beautiful. The shadows are meant to be dark, by the way, Sam. Intentionally so. Sorry, I'm just going to show you why. That is the particular look we're going for. That depth of shadowing. And the stark contrasts. Now, in reality, by the way, I don't know if anyone knows this about these sort of photos, is that actually isn't black. That is the exposure on the lens making it look, or the way the exposure works making it look black. It actually has stars in it. There's comments about this. Like, you can actually see stars. But the way it's done, yeah. So in theory, yes, it is too dark. In reality, that's not what it would look like. But the way in which people have visualized the moon due to photos like this is these very dark, sharp, contrasting shadows off of the terrain. That is definitely not a real photo. At least I don't think it is. That looks way too plasticky. But yeah, no, that's why the shadows are that way. I got sidetracked in my outro on the shadow thing. I'm now going to just look at moon pictures. That wasn't Apollo 11. That photo's too clean. Unless it's been remastered since then. Hilarious thing is, people say, oh, it's waving in the breeze. Actually, it isn't waving at all. Just for people to know that isn't it waving. It's what is the result of what's happening in this picture. There's a rod at the top of it that they couldn't get to fully extend, and they're actually struggling. The even more hilarious part about it was they blew the flag over. Seriously, when they took off, they didn't realize how close. Like they didn't realize, but they didn't account for how close they were. So it literally got blown over. You can see a video of it falling down, kind of thing. So other Apollo missions, they actually had a specification about how far they had to walk to put the flag in. Also, I think they fixed the rod issue. First, color camera to the moon didn't work because the guy aimed it at the sun and fried out everything in the circuitry. Apparently Hasselblad's, I think it was a Hasselblad at least, I like Hasselblad's, don't like direct sunlight like that, especially when there's no atmosphere. Also, as a side note, in case you also didn't know, our sun isn't yellow. Any picture of the sun you see from space is usually slightly changed to make it more yellow. Our sun's a white star, not a yellow star. It's not a yellow dwarf, it's a white dwarf. Small star, yeah. All right, sorry, other random space facts. One, the sky isn't blue. It really isn't. While the Earth orbits the sun, the moon does not orbit Earth. What else is there? Jupiter doesn't orbit the sun. Sorry, I just have to think of the other really random. I always post this up on Facebook every few years, like my 5 random favorite science space related facts. I think we've done all but one of them. We did all of them. So yeah, my reminders, it's 4. Sol is white, not yellow. Jupiter doesn't orbit Sol. The sky isn't blue. The Earth orbits Sol. So that's 4. That's one we already knew. To deny anybody who thinks the Earth is flat, or to deny anybody who thinks the sun revolves around the Earth. But the moon does not orbit the Earth. All of those are factual, scientifically backed up statements, not conspiracy theory statements. No, Noxy. I would agree because I grew up when I was at Pluto. But the reason why all of those things are all true. Our sun is actually white. Our atmosphere makes it look yellow, which is why we have to change it in photos. Jupiter's mass is large enough that its effect on the sun, on Sol, is actually greater than, the Earth's, and greater than the overall power of the sun. Gravitational pull. It's actually not greater than the overall sun's gravitational pull, like it would still pull Jupiter in, but it is large enough that it counteracts the effect enough that the Jupiter actually orbits a spot in front of the chromosphere of the sun. And technically, the sun also orbits that spot, so they orbit each other from a technical standpoint. Now, just like we know the Earth orbits the sun, so I'm not going to go into that one. But just like the next bit, the moon doesn't orbit the Earth, it orbits the sun. Just like me saying the Jupiter thing, these are factual statements, yes. But in the grand scheme of things, and from a local perspective, like I said earlier, everything on Earth is non-Euclidean geometry, but it's all so close that we think about it in sense of, I'm talking about buildings, by the way, not like my computer screens. But we think about it in sense of regular sort of geometry, Euclidean geometry, and not non-Euclidean geometry, when in reality it is non-Euclidean geometry, but the scale is so small for us, or so big, whatever the wording there is, that it doesn't matter. So from that technical standpoint, yes, Jupiter orbits a spot in front of the sun, not the sun itself. But in terms of like astronomical measurement, dude, Jupiter orbits the sun. Likewise, same with the moon. When you actually pull out enough to look at the orbital pattern and at scale. Oh, sorry, reverse that. When you zoom in enough and look at it at our scale, yes, the moon orbits the Earth. In reality, it doesn't. It actually orbits the sun, and the Earth is a speed hurdle in its way. And if you pull out far enough, the more you pull out, the more you see that sort of pearl effect. And the farther you pull out, the smoother it gets, which is an indication that it actually isn't following the Earth, or that it's actually being bounced around the Earth while it's on its path around the sun. All right. Also, with the blue, that is not just, it's okay. So remember with blue, with scattering, what you're talking about is scattering. There are 3 parts to it. There's Rayleigh, Mia or Maya, and the other one. Our Rayleigh, okay, so ignoring like our atmosphere, ignoring like parts of North America where there's a hole in the atmosphere, and there's thinner spots in the atmosphere, and we have ozone issues and things like that. Ignoring those, our Rayleigh isn't bound to change anytime soon. The other 2 are, and we actually have examples of it changing for the positive. You know, you look at smog-filled cities like Pittsburgh back in the 70s and 80s. That effect you see when there was light shining in photos is that scattering of the particles in the air. So dust particles, water particles, etc., yes, affect the scattering. In terms of our Rayleigh absorption, however, why we think of the sky as blue overall, not the quality of blue, not the tone of blue, not the accents to it, it's actually an optical illusion that our eyes play on us. So for example, the color magenta doesn't exist. It's an impossible color. And I can't remember if the sky is an impossible color and we see blue as a result of it. Yeah, I know it's an impossible color. If I remember correctly from my physics class way back when. I could be getting the math behind this wrong, but basically there are 2 colors we're seeing when we look at the sky, and they are either contradictory colors, so an impossible color, and we see we make up a shade to fill in. I don't think that's actually true. I don't think it's an impossible color. I think we see 2 different wavelengths, and our eyes choose to process the easier of the 2 wavelengths. So until we F over the atmosphere completely, while it might change from a local perspective, as you get above the dirt and stuff, assuming it isn't in the atmosphere, assuming we don't scorch the atmosphere, which would change the Rayleigh, then yeah. But you know, it will change with time, of course. All right, sorry for the long ramble outro at the end there. Also, for anyone who's like, why does this look so weird right now? It's because I'm in unlit mode. There you go. Right there are the dark shadows. Also, there's no atmosphere here, which is really cool. But yeah, I have more to do with this. You'll see more of it later on. So no neon green sky for my grandchildren. I mean, if we scorch it, probably won't be neon green, but the fields might be neon green. All right, I really do need to eat because I am starving. So I will see everybody either on Monday for the tutorial, which I won't be live for, but it'll be released on Monday, or Friday for the community stream at 5 o'clock British Standard Time, or on Saturday at 12:30, assuming I don't have any, housework being done, here on YouTube. All right. With that said, I look forward to seeing you then, and I hope that you have a wonderful day. I meant to have that all minimized before we came back. Hi all, I'm still technically here while I find the end stream button. Alright, see you all later.